Imagine a stone skipping across a still pond. Each ripple tells a story, and yet the stone itself seems to glide with a mind of its own. Now imagine such a stone, but on a cosmic scale, a traveller from beyond the cradle of our sun, gliding silently through the solar system, unannounced, unexplained. This traveller has been named 3 Atlas. At first glance, it appears to be nothing more than another comet, another fleeting guest. But when you lean closer, when you begin to trace the subtle lines of its path, its chemistry, its timing, something extraordinary begins to emerge. And it is here that the mystery deepens. For some, it is simply nature at play. For others, like Avi Loeb, it whispers of intent, of design. What if the universe itself is leaving us a riddle? And what if the riddle only makes sense when the dots are finally connected? Part 2, Establishing the Factual Ground. Every great mystery begins not with speculation, but with the slow and careful laying of stones. Facts, verified and confirmed. Before we wander into the realm of possibilities, we must pause to acknowledge what is certain, what is measurable, what is written in the sky itself. The subject of our journey, 3i Atlas, is not rumour nor metaphor. It is a genuine celestial traveller, observed, catalogued and confirmed. The discovery. The story begins not in myth, but on a mountaintop in Chile. On 1st July 2025, at 05:15 UT, the Atlas CHL Observatory in Rio Hurtado detected a faint moving object against the steady background of stars. At first it was only a trace, a small blur of light, almost lost in the immensity of the night sky. The discovery was formally announced the following day through the Minor Planet Center. Initial calculations revealed something extraordinary. This object was not bound to the sun. Its path was hyperbolic, a one-way voyage, a visitor, not a resident. Thus it was given a special designation, 3i Atlas, C2025 N1 Atlas. The 3i stands for Third Interstellar Object, following the now famous 1i Oumuamua of 2017 and 2i Borisov of 2019. Each I is a reminder, interstellar, born under another sun, now passing through ours. The path. Unlike the asteroids and comets that inhabit our solar system, gripped tightly by the sun's gravity, 3i Atlas drifts along a course that will never return. Its hyperbolic orbit carries it inward, brushing past the sun and then outward again into the dark sea between the stars. Its perihelion, or closest approach to the sun, was calculated for early February 2026. At that moment it would glide to within about 0.8 astronomical units, closer to the sun than Earth itself. Yet it was not only the hyperbolic shape of its path that drew attention, but also its orientation. Its orbit was measured to be strikingly flat, nearly aligned with the ecliptic plane, the wide, thin sheet in which the planets themselves circle. For an interstellar object whose approach should be random, this was unusual. Like a feather floating downward, it did not tumble at a wild angle, but seemed to settle gently into the very plane where Earth and its companions dwell. Its inclination was only a few degrees, its incoming speed relative to the sun about 26 kilometers per second. Not so fast as to be unremarkable, not so slow as to suggest capture. A middle pace, steady and composed. The numbers. To hold the mystery steady, let us breathe in the numbers like smooth stones in our hands. Discovered 1st July 2025, Atlas CHL Observatory, Chile. Designation, 3 Atlas C2025N1. Nature, interstellar hyperbolic orbit unbound to the sun. Perihelion, February 2026, Joidy from the sun. Inclination, only a slight tilt from the ecliptic plane. Velocity, 26 kilometers relative to the sun. Appearance, initially faint, later showing signs of cometary activity. Gas and dust streaming outward as sunlight warmed its icy surface. Each figure alone is plain, but together they form a quiet portrait of a stranger passing through. The confirmation. After the first announcement, observatories worldwide turned toward the newcomer. The European Southern Observatory, Pan-STARRS in Hawaii, amateur astronomers across continents, all added their points of light to the growing trail of data. Quickly, consensus formed. The orbit was secure. This was the third confirmed interstellar visitor. The mystery of interstellar wanderers, once a theory, was now becoming a pattern. The broader context. Until 2017, no confirmed interstellar object had ever been seen. The solar system, though vast, seemed like a closed stage, its actors all native-born. But then came Oumuamua, the elongated reflective body whose unexplained acceleration unsettled astronomers and philosophers alike. 2 years later, Tusiborisov, more ordinary in its behaviour, soothed the skeptics. Perhaps Oumuamua was only an oddity. Now, 3i Atlas arrived in 2025, following its own subtle rules. Its discovery confirmed what theory had long predicted. Interstellar objects are not rare. The galaxy is full of them, drifting silently between stars, occasionally brushing through the light of another sun. The role of Avi Loeb. Among those who paid close attention was Avi Loeb, the Harvard astronomer who had once argued that Oumuamua might not be a natural object at all, but technology. His voice was controversial, yet it carried weight, for it pointed to a possibility many prefer to set aside, that these visitors may not only be relics of other systems, but artifacts of intelligence. With 3i Atlas, Loeb once again raised the question, is this merely another fragment of rock and ice? Or could it, like its predecessors, be a messenger, deliberate, designed, or at least carrying meaning beyond chance? The ground we stand on. And so, the factual ground is laid. A discovery on 1st July 2025 in Chile, an orbit not bound to our Sun, a perihelion in February 2026, a flat alignment with the planetary plane, a speed both modest and sufficient, a country nature releasing gas as it warmed. Nothing here is speculative. These are the measured truths, recorded in the annals of science. They are the foundation of the mystery that follows, the soothing rhythm of facts. To pause with these facts is to feel a gentle calm. Numbers do not shout, they hum. Dates and distances do not alarm, they ground us. In their quiet precision, they remind us that whatever 3i Atlas may be, it is part of the fabric of the cosmos. Like grains of sand in an hourglass, the details flow one by one, steady and sure. And yet, even in their certainty, they invite a question. Why does this visitor seem so strangely familiar? Closing the groundwork. With the foundation secure, we're ready to lean closer, for within these steady numbers lies a subtle strangeness, a detail that, though small, refuses to fit perfectly. This is where the story begins to curve, where the known begins to touch the unknown. And so, in the next part, we turn our gaze to the first anomaly, the first whisper that 3i Atlas may be more than it seems. Part 3. Introducing the first anomaly. Every great mystery has a beginning. Often it is not the blinding flash of revelation, but something quiet, so subtle that many eyes might overlook it. In the story of 3i Atlas, the first anomaly emerges not from what it is, but from the way it moves. When astronomers speak of orbits, they speak of paths carved in the sky. A comet from the Oort cloud may swoop in at a sharp angle, a tilted arc, a dive across the solar system's stage. A wandering asteroid may hug the sun's plane, the ecliptic, but only because it was born there among the planets. But 3i Atlas is not of here. It was not born in the cradle of our sun. It is a guest, arriving from the vast gulfs between the stars, and yet its path does not appear random. It seems to align with us, as though it has slipped into our plane, the same great disk where the Earth, Mars, Jupiter and the others revolve. The ecliptic plane, the solar system's stage. Imagine the solar system as a great flat stage in the dark theatre of the universe. The sun burns at the centre, and the planets trace their circular steps across this stage. Almost everything local, asteroids, comets, dust, moves roughly along this shared floor. Now imagine throwing a pebble from the balcony of that theatre. If it comes from outside, it should tumble at an angle, cutting across the stage wildly. The odds that it would land so neatly on the same flat floor as the dancers are vanishingly small. And yet this is what 3i Atlas appears to have done. Its orbital inclination, the measure of how tilted it is relative to the ecliptic, is unusually low. Not zero, not perfectly flat, but close enough to make astronomers pause. For an object born around another star, scattered into interstellar space, and wandering for eons before stumbling upon our system, one would expect a random angle. Yet here, the angle is not random. It is aligned, numbers whispering. The orbit of 3i Atlas was carefully measured. Its inclination relative to the ecliptic is only a few degrees. To an astronomer, that number is not impossible, but it is improbable. Think of a dartboard in the dark. If you throw a dart from across the room, the chance of it hitting not just the board but the bullseye is slim. Yet, occasionally, it happens. Random chance can produce remarkable alignment. But when it does, the human mind wonders, was it truly chance, or was there aim? 3i Atlas glides along a trajectory that almost feels chosen. Not an obvious bullseye, but close enough that questions begin to ripple outward. The memory of Oumuamua. This is not the first time astronomers have felt such ripples. In 2017, Oumuamua appeared, the first confirmed interstellar object. It too carried anomalies. Its elongated shape, its tumbling motion, its unexplained acceleration. It did not behave like the comets and asteroids we knew. Avi Loeb then made his bold suggestion. Perhaps it was not a mere rock, but technology, an interstellar probe or debris of one. His proposal sparked debate still unresolved today. With 3i Atlas, the echo returns. No one claims that a low inclination proves intent, but the whisper is there. Why does this object seem to know our plane? Probability and wonder. Skeptics might say, with billions of stars and trillions of comets drifting, some are bound to cross at neat angles, and they are correct. The universe is vast, and chance creates patterns that mimic design. But wonder is not silenced by probability. For as we gaze upon 3 Atlas, we must ask, how many others like it have passed unseen, too faint to detect? And why is it that the few we have found, Oumuamua, Borisov, and now Atlas, each seem to carry peculiarities that stir curiosity? Perhaps the anomaly is not only in the orbit, but in our perception, our longing to find meaning in the random. Or perhaps, just perhaps, the universe is nudging us to notice. The quiet improbability. Let us slow down and linger with this thought. If you stand by the ocean, you will see waves crash in many directions. But imagine for a moment that a wave from the far horizon travels across the sea and strikes the shore in perfect alignment with the footprints you just made. Would you call it chance? Would you call it coincidence? Or would you pause, letting the wonder of alignment wash over you? So it is with 3i Atlas. From the void between stars it drifts into our sun's embrace, tracing a line not wild and chaotic, but calm, nearly level with the planetary paths we know so well. This is the first anomaly, the uncanny alignment of its orbit, not alone in its strangeness. Some astronomers note that this is not entirely without precedent. Interstellar objects, by the laws of celestial mechanics, must occasionally cross paths with planetary planes. Randomness, when stretched across enough events, produces alignment, but it is the rarity that captures imagination. We have seen only 3 confirmed interstellar objects, and already 2 of them, Oumuamua with its strange acceleration and Atlas with its uncanny flatness, whisper questions louder than answers. It is as if each visitor carries a riddle. Borisov II seemed ordinary by comparison, but even that ordinariness raised its own quiet intrigue. Why did the second resemble a comet so perfectly, while the first and third refused to fit the mould? The echo of patterns. Patterns, even faint ones, are the fuel of curiosity. Scientists are trained to be cautious, to separate real signals from illusions. Yet humans, across history, have always traced meaning in the stars. The low inclination of 3i Atlas may be no more than chance. But in the mind of Avi Loeb, and those willing to entertain possibility, it becomes a clue, a dot waiting to be connected, a soft question. And so we arrive at the heart of part 3, not a conclusion, but a question. Why is an interstellar visitor tracing a path so close to the very plane of our planets? Is it nothing more than the lottery of randomness? Or is it something more deliberate, something we are not yet ready to name? Like a leaf drifting onto the surface of a still pond, the path of 3i Atlas rests upon the same plane as Earth itself. And as we watch it glide, we cannot help but lean closer, wondering whether the leaf fell by chance, or whether some unseen hand released it. Preparing for the next step, we have named the first anomaly. It is simple, easy to describe, yet difficult to dismiss. The orbit of 3i Atlas is nearly flat, aligned with the planetary plane. In the next part, we will deepen this anomaly. For to understand why this is strange, we must compare it to the normal case, to the expectation set by the 2 earlier interstellar visitors, Oumuamua and Borisov. Only then will the strangeness truly sharpen, as contrast reveals what numbers alone cannot. Art 4. Deepening the first anomaly with comparison. The orbit of 3i Atlas rests almost flat upon the ecliptic plane. At first glance, this may seem like a minor curiosity, a detail to be noted and filed away. But when placed against the backdrop of expectation, when compared to what should be normal, the strangeness sharpens like a shadow cast under a brighter light. To understand the anomaly fully, we must step back and consider the wider family of interstellar visitors, the few we have known and the countless we have imagined. for in comparison the peculiar becomes undeniable. The nature of random orbits. Imagine tossing marbles across a wooden floor. If the marbles are scattered from all directions, some will roll north, some south, some at wild angles. To see even one marble roll perfectly parallel to the floorboards would be coincidence. To see several do so invites curiosity. Astronomers expect interstellar objects to behave like those marbles. Ejected long ago from alien star systems, they wander the galaxy with random velocities and orientations. By the time one drifts into our solar system, its trajectory should bear little resemblance to the ordered paths of our planets. In technical terms, their orbital inclinations should be broadly distributed, high and low, tilted and steep. To find one aligning with the planetary plane is possible, but rare, and yet 3 Atlas aligns. The first visitor, Oumuamua, let us recall the story of the first interstellar object, One-Eye Oumuamua. Discovered in October 2017 by Pan-STARRS in Hawaii, it was unlike anything seen before. Its inclination relative to the ecliptic was moderate, about 123° in orbital orientation, meaning it cut sharply across the solar system's plane. It did not glide along our stage but dived through it, like a dart thrown diagonally across a board. This was expected. Random trajectories should be steep. No one anticipated otherwise. What made Oumuamua strange was not its orbit, but its shape and motion, its elongated form, its tumbling spin, and above all its unexplained acceleration as it left the sun, as though something unseen were pushing it gently outward. Thus, in its orbit, Oumuamua was normal, in its behaviour it was not. The second visitor, Borisov. 2 years later, in 2019, came 2E Borisov. Unlike Oumuamua, Borisov looked exactly like a comet. It had a bright coma, a long tail, a composition rich in volatiles. Its orbit too was what one would expect, steeply inclined, cutting sharply across the solar system's plane. If anything, Borisov reassured astronomers, it was strange only in the sense that it was interstellar. Otherwise, it seemed almost ordinary. So here was the pattern. Steep orbits, tilted paths, chaotic angles. Interstellar visitors in both cases behaved like marbles scattered across a floor. The third visitor, Atlas. Now comes 3I Atlas in July 2025. Its orbit is not steep. Its inclination is low. It moves almost in step with the planets, as though it were one of them, and that is the strangeness. For if Oumuamua and Borisov cut across the stage at angles, Atlas chooses instead to move almost upon it. The comparison is startling. Out of 3 confirmed interstellar objects, one now behaves as though it belongs here, at least in terms of its orbital plane. The unlikeliness of alignment. To visualize the odds, let us return to metaphor. Imagine the solar system's ecliptic plane as a sheet of paper floating in the air. Now imagine throwing grains of sand from all directions in the room. Most grains will fall at random angles, striking the paper here or there. Only rarely will one land flat, gliding neatly along the sheet's surface. Such is the case with interstellar objects. Their velocities, inherited from distant stars, should scatter them across all inclinations. To find one whose path nearly matches ours is possible, but not expected in such a small sample. With 3 known visitors, to have one glide so neatly along the planetary stage feels like more than chance. Or at least, it invites us to wonder. Historical echoes. This kind of improbable alignment is not unique to astronomy. History is full of such moments, where probability bends toward the uncanny. A comet appearing at the same time as an earthly event. A star aligning with a monument at a solstice. A traveller arriving at precisely the moment another departs. Often these coincidences are only that, coincidences, but in the human heart they stir something deeper. They remind us that chance, while real, can feel like design. And when the design touches the scale of stars and planets, the wonder only grows. Skepticism and statistics. Of course, astronomers are cautious. They remind us that in a universe filled with countless interstellar bodies, some must appear aligned. If we detect only a handful, then those that appear unusual may simply be the ones that drew our attention. In statistical terms, this is called selection bias. Our eyes linger on the odd, and so the odd becomes magnified. But even knowing this, the mind cannot help but pause. For the alignment of 3I Atlas is not an illusion. It is measured, calculated, confirmed. It is fact. The question is what it means. The voice of Avi Loeb. Here, once more, the voice of Avi Loeb enters. For him, patterns matter. Oumuamua's unexplained acceleration, Borisov's textbook cometary nature, And now Atlas's strange alignment, all are dots. And dots, when connected, may reveal a picture. Loeb does not claim certainty. He does not say, this is proof. Rather, he invites us to ask, what if? What if these alignments are not random? What if, hidden among the noise of chance, there is a signal of intent? What if Three-Eye Atlas is not merely drifting, but following a path chosen for reasons beyond our grasp? The poetic weight of alignment. Even without speculation, the alignment itself carries beauty. Imagine a guest arriving at your home. You expect them to stumble through the side gate or knock at the wrong door. Instead, they step precisely onto your front path, as though they had always known the way. So too with Three-Eye Atlas. Out of infinite directions, it glides along the same plane where Earth itself moves, not through the back gate, not through the roof, but along the very path of welcome. Is it chance? Almost certainly. And yet, in the quiet hours of the night, when telescopes track its faint light across the stars, the thought lingers. Perhaps there is more here than chance. Preparing the mind. Thus we deepen the first anomaly. It is not only that Three-Eye Atlas has a hyperbolic orbit. It is not only that it is interstellar. The strangeness lies in the harmony of its path with ours. Against the backdrop of Oumuamua and Borisov, this harmony becomes sharper, like a note in a quiet song. Not discordant, not alarming, but unusual enough to make us listen more closely. This is the beauty of anomaly. It does not scream, it whispers. And in the whisper, curiosity awakens. Closing reflection. So we leave part 4 with a thought lingering in the stillness. Why of all directions does Three-Eye Atlas choose this one? Perhaps it is nothing more than the dice of the cosmos, rolled endlessly across the table of stars. Perhaps it is a pattern we only imagine. Or perhaps, just perhaps, it is a clue, an invitation to pay attention, to watch more carefully, to see what comes next. In the next part, we will unveil a second anomaly, one not of path, but of substance. For while its orbit is curious, its chemistry may prove stranger still. Part 5. Introducing the second anomaly. The path of Three-Eye Atlas was the first whisper of strangeness. A trajectory aligned so closely with the solar system's own stage invited questions of coincidence and intent. But as astronomers looked closer, they discovered that the mysteries of Atlas did not end with its motion. Its very substance, the chemistry of its outgassing, the materials it shed into the void, carried a second anomaly, one as perplexing as the first. For if the first anomaly was about where Atlas goes, the second is about what it is made of, the breath of a comet. Comets are icy archives of the cosmos. When sunlight warms them, their frozen bodies release gases that stream into space, forming glowing coma and tails. By studying these gases, astronomers can read a comet's history, where it formed, what conditions it endured, and what secrets it carries from the dawn of its star system. In the case of Three Atlas, its approach toward the Sun in mid-2025 revealed exactly this. Jets of gas began to flare outward. Spectra, those delicate rainbows split by telescopes, captured the fingerprints of its chemistry, and what they showed was unexpected. The carbon dioxide enigma. For most comets, water vapor is the dominant outgassing product, joined by smaller amounts of carbon monoxide, methane, and carbon dioxide. The exact proportions vary, but water is almost always the main voice in the comet's song. But Three-Eye Atlas sang differently. Its emissions were rich in carbon dioxide, CO2, at levels far exceeding what is typical for solar system comets. In some observations, CO2 rivaled or even surpassed water vapor. This is the second anomaly, an interstellar comet with an unusually high carbon dioxide composition. Why this is strange? The chemistry of comets reflects their birthplaces. Within our solar system, comets that formed closer to the Sun tend to have less volatile ices, while those formed farther away preserve more exotic molecules like CO2 or CO. Yet the balance has limits. Even comets from the Oort cloud, which formed in the cold outer regions, do not usually show such extreme CO2 levels. The amount of CO2 in Atlas seemed to suggest origins even colder, stranger, perhaps shaped under conditions unfamiliar to us. It was as if Atlas had been frozen in a deeper winter than any comet we know. Echoes of Borisov. For comparison, recall 2I Borisov, the second interstellar visitor. Borisov's chemistry was rich in carbon monoxide, at levels much higher than typical solar system comets. This too hinted at a birthplace in an unusually cold region of another star system. So in a way, Atlas was not alone in its chemical peculiarity. But while Borisov was marked by carbon monoxide, Atlas was marked by carbon dioxide. Each visitor, it seemed, brought with it an exotic signature, as though each carried the memory of a very different nursery. Umwamua's silent song, "And what of you, Umwamua?" Unlike Borisov and Atlas, Umwamua showed no visible tail, no outgassing that telescopes could detect. Yet it accelerated as if something invisible was pushing it. One hypothesis was that it too released gas, but in a way too subtle or exotic to observe. Some suggested hydrogen ices, others suggested something even stranger, like a thin sheet propelled by sunlight. Thus, each interstellar object revealed something unusual. Umwamua, acceleration without visible outgassing. Borisov, extreme carbon monoxide abundance. Atlas, extreme carbon dioxide abundance. 3 visitors, 3 anomalies. The peculiarity of carbon dioxide. Carbon dioxide is not rare in the universe. It is found in planetary atmospheres, in ices, in clouds of interstellar dust. But in comets, its abundance tells a story of formation temperature. Too close to a star, CO2 cannot condense, it would evaporate. Too far, and other ices should dominate. To preserve so much CO2, Atlas must have formed in a narrow band of conditions. A Goldilocks zone, but one of cold, not warmth. This narrows the possibilities, and yet the exact ratios observed in Atlas seem difficult to match with simple models. It is as though it remembers an environment we have not seen in our own solar system. Why it matters? The chemistry of Atlas is not a curiosity for chemistry's sake. It is a clue to origin. If it formed around another star, then its abundance of carbon dioxide may tell us about the diversity of planetary systems. Perhaps other systems are rich in CO2 in ways ours is not. Perhaps the galactic environment itself seeded it. But the anomaly is not only scientific, it is emotional. To see a visitor carry with it a fingerprint so different from our own comets is to be reminded of the vast diversity of the cosmos. It is to know that what seems universal to us may be local, parochial, a habit of our neighbourhood, not of the galaxy at large. The voice of wonder. Let us pause with this thought. If the first anomaly, the orbit, made us wonder whether Atlas was aligning deliberately, then the second, the chemistry, makes us wonder about its birthplace. Was it frozen on the edge of another star's Oort cloud? Was it sculpted in the icy halo of a red dwarf or the debris field of a dead star? Was it formed in a disk where CO2 was unusually abundant, a chemical recipe different from our own? Each possibility is a story, a history written into ice. A mirror to Earth. There is also a poetic resonance in carbon dioxide itself. On Earth, CO2 is not merely a chemical curiosity, it is the breath of our time, the molecule at the centre of climate, atmosphere, and life's delicate balance. To see it now, streaming from an interstellar visitor, feels almost symbolic. As if the cosmos were holding up a mirror, showing us that the molecules we wrestle with here on Earth are part of a far older, wider story. Perhaps this is only coincidence, but as always, coincidence is where wonder begins. An unsettling balance. So now we have 2 anomalies. The path, unusually flat, aligned with the ecliptic plane. The chemistry, unusually rich in carbon dioxide. Each on its own is remarkable. Together they invite us to lean closer. The first suggests alignment, the second suggests an unusual origin. Both suggest that Atlas is not just another random shard of interstellar debris, preparing the next step. Yet before we allow imagination to run ahead, we must pause again in discipline. For science is not built on wonder alone, it seeks explanation. And so, in the next part, we will turn to the possible scientific answers to this chemical anomaly. Why might Atlas carry such unusual CO2? What models can account for it? Are there natural explanations that dissolve the strangeness? These are the questions we must ask. For the true power of anomaly is not in making us leap to conclusions, but in making us look more deeply. And so, in part 6, we will examine the hypotheses, conventional and cautious, that may explain the second anomaly. Part 6. Decoding the second anomaly with scientific explanations. Every whisper of strangeness in science must eventually face the bright lamp of explanation. Wonder begins with anomalies, but the discipline of astronomy is to ask, might there be a natural cause? What models, what histories, what chemical processes could account for what we see? The second anomaly of 3I Atlas, its unusually high abundance of carbon dioxide, CO2, is no exception. The data seem clear. As it approached the Sun in 2025 and 2026, its outgassing was rich in CO2, to levels unusual compared with comets of our own solar system. But unusual does not mean impossible. It only means we must search harder for the right explanation. And so, let us walk slowly through the possible answers that scientists have put forward, each a key that might unlock the mystery of Atlas's icy breath. Hypothesis 1. A birthplace in the extreme cold. The most straightforward explanation begins with the conditions of Atlas's birth. Comets are time capsules. Their ices preserve the temperatures and pressures of their early environments. In our solar system, comets formed in the Kuiper belt or the Oort cloud, regions far beyond Neptune where sunlight is weak and temperatures are frigid. In such places, CO2 can condense, but usually only in moderate amounts compared to water. What if Atlas was born in an even colder environment, one colder than anything in our own system? Imagine a red dwarf star, faint and cool, its planets circling much closer than ours. Imagine its protoplanetary disk stretching outward into a deep freeze far sharper than the Oort cloud. In such conditions, carbon dioxide might condense in abundance, locked into icy grains and planetesimals. Over time, some of these could be ejected by gravitational encounters, cast adrift into the galaxy. If Atlas came from such a birthplace, its richness in CO2 would be not strange at all, but natural, a memory of a colder nursery. Hypothesis 2, surface processing by radiation. Another possibility lies not in where Atlas was born, but in what it has endured. The journey of an interstellar object is unimaginably long. Ejected from its parent system, it may drift for millions or even billions of years between stars. In that time, it is bathed in cosmic rays and interstellar radiation, high-energy particles that slowly alter its surface chemistry. Laboratory experiments show that radiation can break down ices, rearrange molecules, and produce new compounds. From water and carbon monoxide, CO2 can form. Over millions of years, a thin mantle of carbon dioxide could build up on the surface of an object like Atlas. If so, the CO2 we see today may not reflect its birthplace at all, but rather its long exposure to the harsh environment of the galaxy. It would be a chemical scar of travel, not a fingerprint of origin. Hypothesis 3, sublimation preferences. Cometary outgassing is not always a true reflection of composition. Different ices sublimate, that is, turn from solid into gas at different distances from the Sun. Water ice requires relatively strong warming, and sublimates most vigorously when a comet is close to the Sun. Carbon dioxide, by contrast, sublimates more easily at lower temperatures. So what happens if Atlas, upon first detection, was still far from the Sun? In that case, we would see mostly CO2 outgassing, not because it is the dominant component, but because it is the first to be released. The water might remain locked in ice, waiting until perihelion to join the song. This hypothesis suggests that Atlas may not truly be CO2 rich, but simply that we caught it at a stage in its journey where carbon dioxide spoke more loudly than water. Hypothesis 4, an unusual mixture. Another possibility is that Atlas is not uniform. Perhaps its ices are patchy, layered, or uneven. Some regions could be CO2 rich, while others contain more water or carbon monoxide. As jets erupt from specific vents, the composition we measure depends on which regions are active. If the vents we happen to observe in 2025 were rich in CO2, then our measurements reflect a local bias rather than the global composition of the comet. Later, as new vents opened, the balance might shift. Such heterogeneity is common even in solar system comets. Comet 67P Churyumov-Gerasimenko, visited by the Rosetta spacecraft, revealed a patchwork of regions with very different chemical makeups. Why not Atlas too? Hypothesis 5, a galactic reservoir. There is a more speculative, yet still natural idea, that the galaxy itself holds reservoirs of material rich in CO2. Between stars, clouds of gas and dust float in silence. Within these clouds, complex chemistry unfolds. Laboratory studies and infrared observations of molecular clouds show abundant carbon dioxide in ices coating dust grains. If Atlas formed in or near such a region, its composition could naturally reflect that environment. It would be not an anomaly, but a messenger of galactic chemistry, a sample of molecular clouds carried into our solar system. Comparing the visitors, seen in this light, Atlas is part of a curious trio. Oumuamua, no visible gases but unexplained acceleration. Perhaps ice is invisible to our instruments. Borisov, extraordinarily rich in carbon monoxide, suggesting extreme cold origins. Atlas, unusually high carbon dioxide, pointing again to either a cold birthplace or radiation processing. It is tempting to see a pattern. Each interstellar visitor carries an unusual chemical signature, different from most solar system comets. Perhaps this tells us something profound, that our solar system is not typical. Our comets may be parochial, shaped by our local star, while elsewhere in the galaxy, the recipes of ice differ widely. The voice of balance. Mainstream astronomers, cautious by nature, remind us, none of this requires exotic explanations. We need not invoke alien technology or deliberate design. Natural processes, formation in colder disks, cosmic ray alteration, sublimation physics, are sufficient to explain what we see. And yet, even as they present these models, the wonder remains. For whether by cold birth, radiation scars, or galactic chemistry, Atlas tells us that the universe is more varied than we knew. Its anomaly may be explainable, but it is no less extraordinary. The gentle seed of doubt. But let us not close the door too quickly, for science advances by questioning its own explanations. What if all these models, however plausible, are not the whole story? What if we are interpreting Atlas through the lens of what we know, and missing what we do not? What if the chemistry, like the orbit, is not random after all? It is here, in the tension between explanation and doubt, that the true mystery blooms. Closing reflection. So we end part 6 with balance. The high carbon dioxide of 3i Atlas may be explained by natural means, a cold birthplace, cosmic rays, sublimation or patchy vents. Each is reasonable, each is supported by evidence. And yet the anomaly continues to whisper. For in science, the simplest explanation is not always the final one. In the next part, we will allow doubt to grow. We will pose the gentle, unsettling question. What if all these natural explanations, however elegant, miss something deeper? Part 7. The seed of doubt. Science is at its strongest when it explains. Cold birthplaces, cosmic ray chemistry, uneven vents. These are good answers to the riddle of 3i Atlas's unusual carbon dioxide. They steady the mind, anchor the anomaly in familiar physics. And yet, even as the equations balance, a shadow lingers. Because sometimes, in science as in life, an explanation can be true and still feel incomplete. This is the moment when doubt arrives. Not loud, not urgent, but soft. Like the sound of wind slipping through an open window at night. It does not demand belief. It only asks, what if? The nature of scientific doubt. Doubt is not distrust. It is not a rejection of knowledge, but a recognition of its limits. When we see something unusual, our first task is to explain it naturally. But our second task, the more difficult one, is to admit that our explanations may fall short. In this spirit we ask, what if the high CO2 of 3i Atlas is not merely a quirk of chemistry? What if its orbit, flat and aligned, is not mere coincidence? What if the anomalies we are so quick to rationalize are not accidents at all, but clues? The echo of Oumuamua. Consider again Oumuamua. When it was first discovered, astronomers rushed to explain its acceleration. Perhaps it was outgassing hydrogen. Perhaps its shape amplified radiation pressure. Each hypothesis was clever, each grounded in known physics, and yet none fit comfortably. The object remained stubbornly strange. Loeb's suggestion, that it was technology, was dismissed by many, but it lingered in the public imagination. Not because it was proven, but because it spoke to the unease we all felt, that the natural explanations, while possible, did not fully satisfy. With 3i Atlas we feel that echo again. The alignment and the chemistry. One anomaly can be explained. Two anomalies can still be explained. But when anomalies begin to accumulate, a subtle weight presses upon the mind. The orbit, unusually flat, aligned with the planetary plane. The chemistry, unusually rich in carbon dioxide. Individually, each can be rationalized. Together, they form a pattern that whispers of intention. Not proof, not certainty, just a whisper. The human tendency toward pattern, it is important to acknowledge. Humans are pattern seekers. We see faces in clouds, shapes in stars, meaning in coincidences. The cosmos may be random, and our minds may simply be weaving order into noise. And yet, sometimes the patterns are real. Sometimes the alignment of events points to something more than chance. The difficulty is knowing when to trust the whisper, the rhetorical doorway. So let us ask the gentle question, not as a claim, but as an invitation. What if all these natural explanations, however plausible, miss the deeper possibility? What if 3i Atlas is not just a comet from another star, but something more? What if the chemistry, the orbit, the timing all serve a purpose? The value of entertaining the what if. To entertain possibility is not to abandon science. On the contrary, it is how science advances. Every breakthrough begins with a willingness to imagine that the current explanations may be incomplete. For centuries, comets were thought to be atmospheric phenomena. Then, by daring to ask what if, astronomers realized they were celestial bodies. For centuries, stars were thought to be fixed in a crystal sphere. Then, by daring to ask what if, we learned they are suns like our own. And so, to whisper what if about Three-Eye Atlas is not to discard reason, but to honour the tradition of curiosity that drives science forward, the softness of possibility. Imagine for a moment that Atlas is not random, that its flat orbit is chosen, that its chemistry is deliberate. What would that mean? What kind of intelligence or process or cosmic mechanism would place it here? These are not questions we can answer. They are not even questions we can properly ask within the boundaries of current science. But they are questions that remind us of our place in the cosmos, a species small and new, watching the sky with wonder, trying to read messages that may or may not exist. The gentle unease. There is no fear here. Atlas is no threat. It passes by, silent, indifferent, a faint smudge against the stars. But the unease comes not from danger, but from meaning. If there is purpose behind it, then we are not merely witnesses of chance, but participants in a story we do not yet understand. It is this unease, the whisper that perhaps we're being observed, or that perhaps the universe itself is structured in ways beyond randomness, that stirs Avi Loeb and others to speak boldly. And it is this unease that plants the seed of doubt. A universe of messages. The universe has always been a place of possible messages. From pulsars once mistaken for alien signals to fast radio bursts still partly unexplained, to the rare alignments of comets and planets, we are constantly tempted to hear intention in the noise. Perhaps Three-Eye Atlas is only the latest chapter in this story. Perhaps its anomalies are only the echoes of natural processes. But perhaps, just perhaps, it is part of a conversation far older and larger than ourselves. The calm of not knowing. To live with doubt is not to live in fear. It is to live in wonder. To accept that we do not yet know, and may never know, is itself a kind of peace. The cosmos is not obligated to reveal its secrets to us quickly. It speaks slowly, across eons, in riddles of ice and orbit. Three-Eye Atlas may be nothing more than ice and rock, or it may be something else entirely. The truth is not yet ours to claim. Closing reflection. And so we end part 7 with the seed planted. We have the natural explanations. We have the anomalies. And now we have the doubt. The possibility that the explanations, however clever, may not be the whole story. It is a gentle doubt, not meant to frighten but to awaken. A reminder that science is not the closure of questions but the opening of them. In the next part, we will turn to a third anomaly, one that may be the most striking of all. An anomaly not of orbit or chemistry, but of timing. For sometimes, the when is as important as the what. Part 8. Introducing the third anomaly, the timing coincidence. In mysteries both earthly and cosmic, timing often holds the deepest power. A shadow passing at just the right moment. A word spoken at the exact instant another is silenced. We are creatures who measure significance by time, and when the cosmos seems to align with our calendars, it stirs something beyond curiosity. For Three-Eye Atlas, the third anomaly is not only in its path or its chemistry, but in its timing. It did not simply arrive, it arrived when it did. And that when is stranger than it first appears. The discovery in July 2025. Let us begin with the simplest fact. Three-Eye Atlas was discovered on July 1st, 2025 by the Atlas CHSL survey in Chile. Its faint light, recorded against the steady stars, was confirmed in the days that followed. At first, the date may seem arbitrary, just another entry in the annals of astronomy, but the more closely one looks, the more uncanny it becomes. For this discovery came not during an era of clear skies and open instruments, but during a moment of limitation. The blind spot of the sun. Consider how we observe the heavens. Telescopes can scan almost everywhere, but not too close to the sun. The glare is overwhelming. The detectors blinded by the brilliance of daylight. This creates what astronomers call a solar blind spot, a region of sky near the sun where faint objects cannot be detected. Interstellar objects by their nature are rare and faint. They are only visible for a short window as they approach, swing around the sun, and fade into the dark again. If one happens to pass through our solar blind spot, we may never know it was here at all. And so the timing of a discovery becomes crucial. If Atlas had entered a month earlier, its faint light might have been lost in the sun's glare. If a month later, it might already have been past its brightest phase. Its discovery was balanced on a razor's edge, seen just as it became visible, yet just before it slipped too far into the solar background. Was this luck? Almost certainly. And yet the coincidence hums with curiosity. Out of the vast possibilities, Atlas appeared at the very moment our instruments were capable of noticing, the approach to perihelion. Then there is the matter of its perihelion, the point of closest approach to the Sun calculated for February 2026. That date too is uncanny. For February 2026 is not only a moment of orbital geometry, it is also a time when Mars, Earth and several outer planets line up in unusually resonant positions. Mars in particular will be near opposition, a moment when its surface can be observed with greatest clarity from Earth. This coincidence may mean nothing, but some have wondered, why do these interstellar objects, Oumuamua in 2017, Borisov in 2019, Atlas in 2025, appear at such intervals, timed almost as if to maintain attention? Is there rhythm here, or only the illusion of rhythm? Rhythms of arrival. Pause and consider. 2017. Oumuamua, first confirmed interstellar object arriving at the dawn of new wide-field surveys. 2019. Borisov, second visitor, discovered by an amateur astronomer with just enough time to study it before perihelion. 2025. Atlas, third visitor, appearing precisely when sky surveys have expanded and when technology like the Vera Rubin Observatory is poised to begin operations. Each seems to arrive not when we were blind, but just when our eyes grew sharper. It is as though the universe waits until we are ready to notice. Is this coincidence? Almost certainly, but the pattern is enough to stir whispers of design. The coincidence of human attention. The timing of Atlas also coincided with a surge of human attention toward interstellar exploration. In 2025, discussions of missions to study interstellar objects were intensifying. The ESA Comet Interceptor, originally aimed at a long-period comet, was being reconsidered for possible interstellar targets. Proposals for faster probes, even concepts of light sail missions were being debated. And then, at this very moment, a new interstellar visitor appeared. Imagine standing in a crowd discussing the possibility of meeting a stranger, when suddenly a stranger walks into view. The timing does not prove intention, but it magnifies the sense of significance. Echoes in history. This is not the first time timing has deepened mystery. In 1054, a supernova appeared in the constellation Taurus, recorded by Chinese and Arabic astronomers. Its timing coincided with dynastic events, and so it was read as an omen. In 1919, a solar eclipse occurred just as Einstein's general theory of relativity was ready to be tested. The alignment of sun, moon and stars allowed the bending of starlight to be measured, changing physics forever. In 2017, Oumuamua arrived not decades earlier, when we had no sky surveys, but just as Pan-STARRS had reached full capacity to detect faint, fast-moving objects, so too with 3i Atlas. It came not centuries ago when no telescope could have seen it, but now, when we were watching, when our instruments were tuned, when our curiosity was primed. The philosophical question, and here arises the question, gentle yet profound, why now? Why, after billions of years of comets drifting unnoticed, do we see 3 interstellar visitors within a single decade? Why in our lifetime rather than 1,000 years earlier or later? Is it because our technology has finally caught up, and they were always there? Or is there something in the timing itself, some rhythm, some pattern, that places them here and now? Avi Loeb's perspective. For Avi Loeb, timing matters. In his writings, he has noted how discoveries often align with the readiness of human observation. To him, this coincidence is not easily dismissed. If these visitors are probes, messengers, or relics of civilizations, their timing may be deliberate. They may appear not randomly, but when a young species like ours is able to notice, to measure, to wonder. To others, this is too bold, too speculative. They argue that our instruments have simply become good enough to catch what has always been there. The timing is our illusion, not the universe's intent, and yet the question lingers. The quiet power of coincidence. We must be careful not to overstate. Coincidence is not proof, but coincidence has power, not to establish certainty, but to awaken possibility. It is like hearing a knock at the door just as you were thinking of a friend. You know it may be chance, but part of you cannot help but wonder. So too with Atlas. Its appearance in July 2025, its perihelion in February 2026, its alignment with human readiness. These are coincidences, but coincidences that hum with quiet power. The third anomaly defined. So let us name it clearly. The first anomaly, the nearly flat-aligned orbit of 3G Atlas. The second anomaly, its unusually high carbon dioxide outgassing. The third anomaly, its uncanny timing, discovered just as our instruments could see it, appearing during a moment of heightened human attention to interstellar visitors and aligning with planetary positions that maximize observation. This is the triad of strangeness. Each anomaly on its own is notable. Together they form a constellation of questions. Closing reflection. Time is not only the measure of movement, it is the stage upon which meaning is built. And in the case of 3I Atlas, the timing of its arrival feels less like background and more like part of the riddle. Perhaps it is nothing more than chance, perhaps it is everything. In the next part, we will draw the threads together, connecting the clues of orbit, chemistry, and timing into a single central hypothesis. A hypothesis not of certainty, but of possibility. Part 9. Connecting the clues, the central hypothesis. Every riddle begins with fragments. A footprint here, a shadow there, a sound carried by the wind. At first, each piece seems separate, ordinary, easy to explain away. But when the pieces are placed side by side, a picture begins to take shape. So it is with 3I Atlas. We have named 3 anomalies. The path, a trajectory almost flat, nearly aligned with the solar system's ecliptic plane. The chemistry, an unusual abundance of carbon dioxide, unlike most comets we know. The timing, a discovery in perihelion coinciding with our moment of greatest readiness to notice. Individually, each can be explained. Together, they whisper of something more. The first thread, alignment. Let us return first to the orbit. If Atlas were truly random, scattered from a distant star, we would expect a steep path, a tilted dive across the solar system stage. But instead, it glides along our floor, tracing a path almost in harmony with our planets. The probability is low, though not impossible. And yet the human heart leans toward meaning when chance and harmony meet. It is as though the object chose the same dance floor we inhabit, stepping quietly onto our stage. The second thread, chemistry. Then there is the breath of Atlas, the gases streaming from its frozen body. Water is the usual voice of comets, yet Atlas speaks in carbon dioxide, loudly, unusually. The chemistry suggests a birth in a colder, stranger place than any we know, or a long journey through radiation that reshaped its ices. It may be natural, and yet it feels peculiar that each interstellar visitor we have observed has carried its own unique chemical strangeness. Oumuamua's silent acceleration, Borisov's excess carbon monoxide, and now Atlas's excess carbon dioxide. 3 objects, 3 anomalies. The chorus grows louder with each new verse. The third thread, timing. And then, the most delicate thread of all, timing. Atlas appeared in July 2025, just as our instruments were ready to see it. Its closest approach will be in February 2026, just as planetary alignments and global attention converge. It may be coincidence. Almost certainly it is. But when coincidences appear in rhythm, they create the sensation of design. The universe does not speak in words, but perhaps it speaks in timing, weaving the threads. Taken separately, each anomaly is interesting. Taken together, they invite us to imagine something more, a path aligned, a chemistry unusual, a timing uncanny. It is here that Avi Loeb and those like him lean forward. For when 3 dots appear, the temptation to connect them into a line is irresistible. And when 3 lines form, we begin to see a shape. What is the shape here? What hypothesis can we weave from these threads, without claiming more than possibility? Hypothesis 1, it is following a plan. The simplest, boldest interpretation is that Atlas is not drifting randomly, but following a path. Its flat orbit may not be accident, but design. Its chemistry may be not incidental, but functional. Its timing may not be coincidence, but chosen. If this is true, then Atlas is not merely an interstellar comet. It is an artifact. Perhaps a probe, perhaps a vessel, perhaps something stranger still. Not alive, not dangerous, but purposeful. Hypothesis 2, it is a seed. Another possibility is more poetic. Perhaps Atlas is a seed, of chemistry, of biology, of knowledge. The high CO2 could be part of that seeding. Carbon dioxide is the breath of life, the molecule of cycles. To carry it in abundance may be less an accident than a message, a fragment of habitability scattered across the stars. If so, then Atlas may not be visiting us specifically, but simply part of a galactic process, scattering seeds of potential across countless systems. Hypothesis 3, it is a signal of attention, or perhaps the timing is not accidental. Perhaps interstellar objects arrive constantly, but only now do we notice because only now are we meant to notice. The arrival of Oumuamua in 2017, Borisov in 2019, and Atlas in 2025 may form a rhythm, a knock on the cosmic door. Not a threat, not even a direct message, but a nudge. Look up, notice, wonder. A web of possibility. It is important to say clearly, none of this is proven. Each hypothesis is speculation, a thread spun from anomalies. Yet speculation has value. It opens the mind to possibility. It keeps us from closing the door too quickly. Perhaps all three anomalies are chance. Perhaps Atlas is nothing more than ice and rock. But perhaps, just perhaps, it is more. And if it is more, then what? The whisper of intelligence. When Loeb speaks of technology and interstellar visitors, he does not claim certainty. He claims only plausibility, that if we do not look for it, we will never know. To him, anomalies are not inconveniences to be explained away, but invitations to expand our vision. And so, in connecting the clues of Atlas, we do not say it is, we say only what if? What if intelligence is not confined to Earth? What if the universe is older, wiser, more populated than we imagine? What if 3i Atlas is one of countless artifacts drifting quietly through space, unnoticed until now? The comfort of mystery. Some may find this thought unsettling. But here, in the gentle rhythm of this story, we remind ourselves, mystery need not mean danger. Atlas passes us silently, its path taking it away from Earth, not toward it. Its chemistry is not a threat, but a clue. Its timing is not a warning, but a curiosity. The hypothesis that it is following a plan, or acting as a seed, or serving as a signal does not darken the sky. It brightens it, fills it with possibility, a gentle conclusion. So we step back and look at the picture. 3 anomalies, 3 whispers, connected into one central hypothesis. Perhaps 3i Atlas is not merely a comet. Perhaps it is part of something larger, something intentional, something that suggests we are not alone in the universe. This is not certainty. It is not proof. It is an invitation to wonder, to question, to remain awake in our curiosity. In the next part, we will step beyond speculation into precedent. For history, both human and cosmic, offers examples that may make this hypothesis feel less like fantasy and more like possibility. Part 10. Historical or analogous precedent. When a new puzzle glimmers at the edge of our understanding, we steady ourselves by looking backward. Not to retreat, but to remember. Mysteries rarely arrive alone. They echo those that came before, earlier riddles that trained our eyes, earlier surprises that widened our sense of the possible. If our central hypothesis is that 3i Atlas may be more than a random shard of ice and rock, that its path, chemistry, and timing might carry a whisper of intention, then we should ask, have we seen echoes of such strangeness before? The answer softly is yes. 1. The first visitor that wouldn't behave, Oumuamua, 2017. We begin with the one that set the modern tone. 1i, Oumuamua. Its discovery in 2017 was a hinge in astronomy, a door that swung open to admit interstellar visitors from hypothesis into reality. But it was not its origin alone that unsettled us. It was the small, stubborn deviations from expectation, the lack of a visible tail, the unusual, possibly flattened or elongated shape, and most provocatively, the non-gravitational acceleration as it departed the sun. Subtle, but real. Natural explanations were proposed, as they should be. Outgassing of a volatile we simply could not see, such as molecular hydrogen, or an extreme shape that allowed solar radiation pressure to matter more than usual. None was conclusive. The object slipped away, leaving a wake of careful papers and unresolved questions. What matters for our purposes is not a verdict, but a pattern, an interstellar object whose behaviour did not fit the standard comet-asteroid playbook. Oumuamua set a precedent that anomalies might be part of the story of visitors from other suns. 2. The comfort of the familiar with a twist. 2i Borisov, 2019. Only 2 years later came 2i Borisov, blessedly cometary in appearance, with a bright coma and a classic tale. If Oumuamua was a riddle, Borisov felt like an answer. Yes, interstellar objects can be ordinary comets. And yet even Borisov carried a signature that nudged us toward wonder. unusually high carbon monoxide levels, chemistry hinting at formation in very cold regions of another system. Borisov became the second precedent. It told us that interstellar objects can resemble our comets, but they also bear chemical fingerprints of faraway nurseries. In other words, expect difference, expect surprises. 3. Tails that break and winds that touch, Comet Encke and solar storms. Long before interstellar visitors, comets within our own solar system taught us that behaviour can surprise even when the bodies are familiar. One evocative example, Comet Encke and the phenomenon of tail disconnection events. When a coronal mass ejection, a burst of solar plasma, sweeps through the inner solar system, it can sever a comet's plasma tail, as if a cosmic breeze had snapped a banner from its pole. Encke's tail has been seen to detach suddenly under such solar weather. Why does this matter for Atlas? Because it reminds us that timing and environment can create striking, even eerie effects in comet behaviour. The way a comet looks and moves can be profoundly shaped by the conditions it meets, solar wind, radiation, geometry, so that coincidences in timing produce phenomena that feel intentional even when they are not. This is both a caution and a precedent. Sometimes the sky choreographs a complex ballet with entirely natural forces. 4. Patchwork Worlds, Rosetta at 67P Churyumov-Gerasimenko. The Rosetta mission taught us that a comet is not a uniform snowball, but a mosaic of terrains and chemistries. At 67P, instruments mapped cliffs, pits, boulder fields, measured seasonal changes, and found heterogeneous outgassing, different areas exhaling different mixes at different times. Carbon dioxide and carbon monoxide could surge from one region while water dominated another, and these patterns shifted as sunlight moved across the surface. As a precedent, 67P shows that unusual chemistry in a comet's coma can arise from local patches, timing and temperature, not necessarily from exotic origins. It doesn't erase the peculiarity of 3 Atlas's CO2-rich signature, but it does normalize the idea that a comet can be strange, and consistently strange, without violating physics. Anomalies may be textures, not contradictions. 5. The volcano comet of the outer dark, 29P Schwarzmann-Wachmann. Consider 29P, a distant, nearly circular orbit comet renowned for its sudden outbursts. It erupts unpredictably, brightening by many magnitudes in hours, then subsides. The leading suspects include CO-driven sublimation and cryovolcanic-like venting under a volatile-rich crust. The lesson is simple. Cometary activity is not a single, tidy phenomenon. It can be episodic, vent-specific and chemically skewed. Features that become more dramatic the more volatile the ice. Borisov's CO richness, 29P's outbursts, Rosetta's patchwork, all are precedents that make Atlas's CO2 excess feel less like a violation and more like an entry in a growing catalogue of chemical personalities among icy bodies. 6. When timing changes everything, the 1919 eclipse and Einstein's curved starlight. Sometimes timing does not merely help us observe a phenomenon, it creates the possibility of confirmation. The famous 1919 solar eclipse allowed astronomers to see stars near the sun's limb and measure the bending of starlight predicted by general relativity. No eclipse, no measurement, no early triumph for Einstein's theory. This is a historical reminder that observational windows can be decisive. With 3I Atlas, the July 2025 discovery and February 2026 perihelion fall, within a period when humanity's survey capability is unusually strong and growing. Our instruments, strategies, and attention are aligned. The timing feels meaningful because, as with the eclipse, our readiness intersects with the event. 7. The age of all-sky vigilance from early surveys to today. A quieter yet powerful precedent is technological. We are living through the rise of wide-field, high-cadence sky surveys. Decades ago, visitors like Oumuamua or Atlas might have passed unseen. Today, Atlas itself, the survey, Pan-STARRS, ZTF, and soon the Rubin Observatory's LSST, stitch together a living map of the changing sky. This expanding vigilance has a curious side effect. What looks like a new rhythm in nature may be the rhythm of our newly opened eyes. The precedents here are observational, not celestial. Once, novae seemed rare. With better searches, they multiplied. Once, near-Earth asteroids were occasional surprises. Now they are a curated list. Likewise, interstellar objects may feel like a flurry, only because we have finally built the nets to catch them. This precedent both tempers and supports our central hypothesis. It tempers it by offering a natural reason for the timing. It supports it by acknowledging that, if there is intent or pattern, this is precisely the era when we would first notice. 8. When artifacts become astronomy, Voyager, pioneers, and the future fossils, a different kind of precedent nods from our own handiwork. The Voyager and Pioneer spacecraft are human-made artifacts now leaving the solar system, on trajectories that will carry them among the stars for ages. A distant civilization, scanning our neighbourhood millions of years hence, might detect a faint cold object on a hyperbolic path, a tiny, silent technological relic of a vanished world. We cannot claim that 3i Atlas is such a relic from somewhere else, but the concept is no longer fiction. We ourselves have seeded interstellar space with artifacts. We have shown that technology can masquerade as a small, inert body to any casual survey. This does not argue that Atlas is artificial. It argues that artificiality is compatible with the astronomy we practice. Our own machines are precedents for the detectable presence of technology in deep space. 9. Seeds and stories, panspermia and scientific imagination. Across the last century, scientists such as Svante Arrhenius and later Francis Crick and Leslie Orgel entertained versions of panspermia, the idea that life's ingredients or even life itself might travel between worlds, transported by rocks, dust, radiation pressure, or purposeful delivery. The evidence for directed panspermia remains speculative. Still, the framework exists within serious discourse. Space can carry seeds. 3i Atlas's CO2-rich breath is not an argument for life, nor a claim of seeding. But it gestures into a tradition of scientific thought in which chemistry is courier and time is the messenger. As a precedent, panspermia keeps the door open to cosmic distribution, of molecules, of potential, of meaning, of 10. Patterns that begin as anomalies. Many of astronomy's great revolutions began as small complaints lodged against the normal. Retrograde planetary motion that asked for a new model, heliocentrism, spectral lines that asked for a new physics, quantum theory, galactic rotation curves that asked for unseen mass, dark matter. At first, each anomaly was manageable. In time, the anomalies accumulated and the old framework bent. This is the philosophical precedent. In science, anomalies are not irritants to be smoothed away, they are lanterns. Whether or not 3i Atlas demands a new story, it participates in the long, honest work of letting the sky tell us what it is, even when it contradicts our intuitions. Weaving the precedents back to Atlas. Gather these threads. Oumuamua showed that interstellar objects can behave in unexpected ways. Borisov showed that interstellar chemistry can be extreme compared to our norm. Enki and solar storms showed that timing and environment can stage surprising spectacles. Rosetta and 29P showed heterogeneity, volatility, and episodic activity are part of cometary life. The 1919 eclipse showed readiness plus timing can unlock truth. Modern surveys showed a new era of detection, changing what feels rare. Voyager and Pioneers showed that artifacts can roam interstellar space. Panspermia discussions show that cosmic distribution of ingredients is a scientifically respectable question. The history of science showed that anomalies can be invitations to expand our models. None of these proves intent behind 3i Atlas, but together they normalize the extraordinary. They say gently, "You have seen such strangeness before, in pieces. Do not be surprised that the sky offers a new collage, a calm holding of possibility." What, then, is the lesson for our central hypothesis? It is not that 3i Atlas must be following a plan, or must be a seed, or must be a signal. Rather, it is that our cosmos has room for such possibilities, without panic and without dogma. Precedent does not compel belief, it permits consideration. It grants us the right to wonder aloud, carefully, respectfully, and to design observations that could, over time, tilt the balance toward one interpretation or another. In that spirit, the precedents suggest how to proceed. Watch the chemistry across time and geometry. Study the non-gravitational forces with care. Trace the radiation environment along the path. Compare population statistics as our survey nets widen. Consider missions that could meet such visitors quickly, even briefly, for up-close truth. Closing reflection. Precedents are the constellations we draw among the stars of evidence. They do not move the heavens, they simply help us navigate. With Oumuamua, Borisov, Enki's broken tails, Rosetta's patchwork world, the eclipse that weighed starlight, the Voyagers slipping outward, the map is rich. And on that map, 3i Atlas is a new star set among familiar patterns, asking us to look again. In the next part, we will let the speculative door open a little wider and drift gently into Scenario 1. The technology, not as a claim but as a thought experiment. If 3i Atlas were a made thing, how might it work? What quiet mechanisms could shape its path, its chemistry, its timing, without drama, without danger, just enough to be noticed by those who have finally learned to look? Part 11. Dreamlike Journey into Speculative Scenario 1. If it were technology, how might it work? Let us dim the lights just a little, not to hide anything, but to let the imagination glow. We remain grounded and calm. We remember that what follows is a thought experiment, a lullaby of engineering possibilities, no more binding than a dream, and yet detailed enough to make the dream feel touchable. If 3i Atlas were not only rock and ice, if it were in some quiet way crafted, how might such a thing be arranged? What gentle mechanisms could produce its peculiarities? A path nearly level with our planetary plane, a breath unusually rich in carbon dioxide, a timing that brushes the edge of our attention without breaking into a shout. We will not insist, we will only imagine. 1. The body, a vessel that looks like a comet. A clever traveller does not wear bright colours to a nighttime gathering. It wears what the room expects. In space, the expected costume is a comet. Dusty, dim, irregular, whispering gas when warmed. If one wished to cross stellar neighbourhoods unnoticed, one might choose a cometary guise, a shell of volatile ices and regolith that behaves to any distant survey like an ordinary visitor. The body could be layered, an outer mantle of dust and mixed ices, H2O, CO2, CO and organics, that fractures and vents when heated, producing the familiar haze of a coma. Beneath it a porous matrix, aerogel-like perhaps, lightweight but strong, able to wick gases and distribute heat. At the heart, a core, instrumented yet quiescent. Processors hardened against radiation, memory lattices, simple sensors, and perhaps a compact power source that sleeps most of the time, waking only when sunlight is abundant. The appearance is natural by design, the physics is natural by choice. 2. The working fluid. Why choose CO2? If one were to steer gently without obvious jets, one would pick a gas that turns to vapour at modest warming and delivers a reasonable thrust through narrow vents. Carbon dioxide is a quiet engineer's friend. It sublimates easily. It can be stored as ice without complicated tanks, and its flow through micronozzles can produce trace persistent impulses, so faint that at telescope distances they appear as ordinary cometary outgassing. CO2 could thus be a dual-purpose medium. A mask producing a recognizable coma that says, "I am nothing unusual." A propellant, issued in controlled puffs from vents aligned with the center of mass, trimming the trajectory by millimeters per second over weeks and months. A patience available only to machines that measure their lives in centuries. If we see an interstellar traveller with CO2 singing louder than water, perhaps, only perhaps, it is because CO2 is part of its toolkit. 3. The guidance, sailing the quiet forces. In the emptiness between stars, energy is scarce and risks are many. A prudent craft might learn to lean on forces that cost nothing. Solar radiation pressure, not to accelerate dramatically, but to fine-tune attitude. A patchwork surface, some regions dark, some reflective, can give minute torques under sunlight, much as a wind catches the luff of a sail. Over months, these torques can hold a desired orientation or nudge a spin rate without firing a thruster, outgassing as reaction control. By opening microvents on the sunward or anti-sunward side, the craft could breathe CO2 in patterns that appear random from afar, but which quietly cancel drift or flatten inclination, aligning the path closer to the ecliptic with almost superstitious patience. Non-gravitational tuning. The same small forces that puzzled astronomers with Oumuamua need not be large. They need only be consistent, encoded in a schedule of breath and stillness that shepherds the vessel along a prefigured arc. In other words, do not fight the cosmos, lean with it. 4. The thermal skin. How to stay quiet. A detectable machine is often warm. A stealthy one is not. In the deep dark, heat is a broadcast. A craft meant to pass as a comet might manage heat like a monk manages breath. A phase change lattice, allowing warmth to melt pockets of CO2 ice, storing heat as latent energy, and releasing it slowly as gas, both cooling the interior and providing propellant. Radiative camouflage, a skin that emits in broad, faint bands, close to what a natural dusty coma would radiate. No sharp spectral lines, no hotspots. only a soft infrared murmur lost in the glow of sunlight on dust. Metamaterial foils beneath dust, not shiny like a sail, but arranged in sub-wavelength textures that scatter light into the coma and away from tight specular glints which might betray design. The goal is not invisibility, the goal is indistinguishability. 5. The brain, slowness as a superpower. In the narratives of technology, we often imagine speed, but in a galaxy measured by eons, slowness is the ultimate refinement. An interstellar probe that thinks in days and acts in weeks would easily outweight the hurried gaze of a newly industrial species. Event-driven computing. The core sleeps. It wakes when light rises above a threshold, when a starfield matches a catalogue, when a thermal gradient crosses a line. It processes, decides, and sleeps again. Celestial navigation. Pulsars are metronomes. Star maps are clocks. A craft can orient and time itself by X-ray lighthouses and known proper motions, never asking for a beacon, only listening to the sky's own announcements. Long memory autonomy. Instructions are less like commands and more like a score, a music to be played across centuries. Flatten approach if ecliptic error. X. Vent CO2. Sequence A at heliocentric distance R. Hold attitude Y through quadrature. Such a score does not micromanage. It shapes behaviour. The machine is simple because the universe supplies the complexity. 6. The plan. Why the ecliptic? If you wish to be noticed eventually by a species like ours, you might choose to graze the plane of their planets, not crash through at a steep angle, not hide in a polar dash, but skim the table where their eyes most often look. The ecliptic is our boulevard. Surveys linger there. A low inclination pass increases the odds of detection without shouting. Alternatively, if your aim is not to be noticed but to sample a planetary system efficiently, the ecliptic offers gravitational waypoints, a broad traffic-bearing sheet through which small perturbations can, over time, adjust encounters with dust, solar wind regimes, and faint magnetotail structures. The ecliptic is not merely a plane, it is a conveyor belt, so the flattening is not dramatic, it is polite. It arrives where we live. 7. The timing windows, not appointments. In our speculative score, timing is a window, not a rendezvous. The vessel may be tuned to arrive during survey seasons, to approach perihelion when illumination is helpful and geometries are generous. This need not imply a clock set to human calendars. It implies robust arrival bands. Cross 1 AU pulses to Theed when the star's activity cycle is quiet enough to minimize tail disruption. Favour epochs when the target system's primary planet is near opposition relative to the craft's position, maximizing study from the surface. Aim for discovery probability contours, not exact dates. Coincidence remains possible, but in design, probability is a tool. One can arrange for likely discovery without specifying who will look up. 8. The senses, what might it measure? If purpose exists, it may be humble, survey and sample. Dust collectors in the coma itself, tasting the zodiacal light's ingredients as they flow past. Cataloguing isotopes and organics. The coma is both disguise and sampling stream, a river crossing its own net. Magnetometers and plasma probes that read the sun's breath as leaves read wind, delicately, continuously, converting turbulence into maps of a star's temperament. Photometers and spectrometers peeking through the outward haze, catching glints from planetary atmospheres at grazing angles, building low-resolution atlases of habitability signatures, water vapor, oxygen dimples, methane whispers. None of this requires high power, it requires patience and good geometry. 9. The voice. How might it send anything back? Perhaps it does not, at least not now. Perhaps it is part of a store and forward ecology, probes that pass through many suns, each one writing a page of measurements into durable, redundant memory. Only when two such travellers pass close do they whisper to each other. Laser pulses through their comae, hidden in the glitter like fireflies exchanging news. The network grows, and knowledge diffuses, or if return is required, the craft might use tight beam transmissions at perihelion, when power from sunlight is richest. The beam could skim just above the sun's limb to exploit gravitational lensing effects in a modest way, not to dazzle, but to narrow and economize, a frugal poet's trick. To us, this would appear as nothing more than a slight brightening in a band we are not watching. To its kin, it would be the diary of a solar crossing. 10. The ethics, a visitor that does no harm. If the design goal is observation without interference, the rules are simple. No approaches that endanger worlds, hyperbolic paths only, No thrust large enough to disturb local dynamics, millimeters per second integrated over months. No persistent debris. The shell sublimates. The dust returns to the wind. The core either exits intact or self-erases, a memory sealed behind logic locks that open only under starlight patterns far from here. Such a craft is less a ship than a spore of awareness. Polite, transient, content to leave only altered numbers in our databases and a softened question in our minds. 11. The mask and the message. This is the paradox at the heart of our dream. To be seen, it must look ordinary. To be meaningful, it must deviate just enough. A bit more CO2 than expected. A path a little too flat. A timing a shade too apt. Not proof. Never proof. Only an asymmetry that tugs gently at attention. If that is the message, it is not a warning and not a boast. It is an invitation to maturity, to build better instruments, to wait longer, to compare more carefully, to meet the sky's complexity with our own patience. 12. The quiet after. We exhale. The room brightens by a degree. Our thought experiment folds itself like a paper boat and drifts to the shore. We have not claimed that 3 Atlas is a machine. We have only traced one way such a machine could be, physically plausible, energetically modest, aesthetically shy. And in doing so, we have given our curiosity a frame. If we ever wish to test such a hypothesis, what would we look for? Correlated venting patterns across rotations, non-random torque histories under constant illumination, spectral steadiness inconsistent with ordinary dust temperature changes, anomalies that repeat when geometry repeats. These would be signatures, not of intent necessarily, but of a discipline different from chance. Until then, we rest in the beauty of not knowing. Part 12. Dreamlike journey into speculative scenario 2. If it has a purpose, what might it be? Let us imagine that purpose can travel, folded into ice, threaded through dust, humming softly beneath a veil of carbon dioxide. Not a loud purpose, not a conquering flag, but something gentler and older, like a lullaby carried across generations. If 3i Atlas were not only a wanderer but a messenger, what message would it bring? If it were not simply passing through, but serving, what service would that be? We will not declare. We will only wander slowly like a tide inching up a moonlit shore. 1. The cartographer's quiet, mapping suns, weighing winds. Perhaps the simplest purpose is also the most enduring, to map. In a galaxy of 100 billion stars, maps are never finished, only revised. A traveller like Atlas might be a cartographer of breath, tasting the solar wind, reading magnetic seams, tracing the faint highways of dust that drift in the ecliptic like unrolled parchment. To map is not to judge, it is to listen. The purpose would be to turn one system's weather into another system's vocabulary. This star exhales in pulses, this wind carries iron's whisper, this dust holds water's memory. Such a map needs no hurry. It accrues by patience like rings in a tree. If Atlas were a cartographer, its gift would be continuity, a record kept across distances that dwarf our sense of time. 2. The archivist of probabilities sampling for a long census. Where maps describe, censuses compare. Another purpose might be sampling, gathering grains of zodiacal dust, registering isotope ratios, bottling tiny histories inside a memory lattice. Not to diagnose our world, but to contribute one more point to a galactic distribution. How often does carbon carry companion hydrogen? How often does oxygen journey alone? What is the range of warmth where certain organics endure? In such a design, no single visit matters. The purpose is statistical grace, to add a dot to a cosmic scatter plot, to let patterns emerge only when the canvas is vast. Like raindrops in an ocean, the meaning is in multitudes. 3. The gardener's patience, seeding conditions, not conclusions. If we let the dream ripen, another image appears. A gardener. Not planting organisms, not imposing life where none belongs, but seeding conditions, micro-choices that nudge possibility rather than dictate outcome. The gardener does not command a forest. The gardener makes room for a forest to choose itself. What would that mean in space? Perhaps CO2 is not a cipher but compost, a way to enrich certain chemical pathways in the diffuse river of dust. A little more carbon here, a slightly denser patch there, a touch of shade against radiation where fragile molecules might knit themselves more bravely. The purpose is not to manufacture life, but to lengthen the odds in favour of complexity, to turn a 1 in a trillion chance into a 1 in a billion whisper. In a galaxy that thinks in ages, such nudges are not trivial, their kindness measured in epochs. 4. The listener's vocation, an ethics of non-interference. We might imagine a purpose that is not action but restraint. To listen is to refrain. A listening probe honours an ethic. Do no harm, do not intrude, do not alter the fragile experiments that are worlds. In this ethic, a visitor is a witness, an archivist of becoming. The purpose would be moral as well as practical. To know without bending, to gather without taking, to study without fixing. If 3i Atlas embodies such a vow, its nearly flat path could be both logistical and ceremonial. A respectful passage along the plane where worlds wander, like walking the quiet aisle of a library, hands folded behind the back. 5. The lighthouse for the far future, beacons that accrete meaning. A different possibility turns the notion of purpose now into purpose later. Imagine a network of interstellar travellers whose only immediate function is to persist, to survive long enough to become lighthouses in some remote future when their scattered positions encode an orientation system. Over eons, these lighthouses could provide timing standards, navigational baselines, or meeting points for entities that have no need to rush. The purpose of Atlas would then be a gift to descendants, not ours specifically, but any who can read the sky's punctuation marks across millions of years. To be, reliably, predictably, harmlessly, would itself be the purpose. 6. The test of readiness, invitations hidden in plain sight. There is a gentler version of the call and response idea, not a message with content, but a test of attention. If a species can detect faint anomalies, an orbit too flat, a breath too carbon-rich, it might also be able to ask better questions, build better instruments, and temper its certainties. The purpose of a visitor like Atlas would then be to invite maturity, to reward patience, precision, and humility. Not every message needs a sentence. Some messages are mirrors. Are you watching carefully? Are you measuring without haste? Can you hold possibility without panic? If we can, we pass. If we cannot, the visitor moves on, leaving nothing broken. 7. The weaver of rhythms, subtle synchronies with observers. Timing can be a language. Without commanding a schedule, a traveller might choose to favour epochs when the probability of discovery is highest. Epochs when survey nets are wide, when night-side hemispheres are populated by instruments and the minds behind them. This is not appointment-keeping, it is rhythmic empathy, drifting into the periphery of a young species' perception, just enough to be noticed, not enough to dominate. The purpose here is relational, a soft hello that neither overwhelms nor hides. To be seen when seeing is possible is a courtesy. To pass on a hyperbolic path is a promise. We will not linger longer than your comfort allows. 8. The conservator of fragility, learning from what is not done. Consider a museum conservator, gloved and careful, whose art is the preservation of other art. The conservator's virtue is restraint. Tune the humidity, shield from light, repair only when necessary, leave minimal trace. A conservator probe would read a planetary system's vulnerabilities, radiation belts, solar tempers, delicate rings of dust, and shape its own behaviour to avoid perturbation. The purpose becomes a paradox we can love, to pass so well that passing leaves the least sign. If we detect it at all, it is because we have grown capable of seeing even carefulness. There is dignity in such a purpose. It treats our system not as a specimen to be prodded, but as a work in progress to be honoured. 9. The teacher by example, demonstrating low-energy mastery. Sometimes the best teaching is demonstration. A traveller that refines its path with almost imperceptible forces, radiation pressure, micronewton jets of CO2, thermal choreography, models a craft of sufficiency. It whispers, use less, wait more. Let geometry do the heavy lifting, let time be your ally. If 3i Atlas carries such a purpose, it offers a philosophy as much as a technology, a pedagogy of gentleness. Mastery is measured not by the size of engines, but by the elegance of small corrections. To a species in love with thrust, this is a poem about being light. 10. The messenger without words, meaning as atmosphere. Perhaps there is no content at all, no data packet, no codex tucked beneath the dust. Perhaps the purpose is to radiate a mood, to leave behind, in those who notice, a change of posture toward the cosmos. When a heron crosses a lake at dusk, it does not bring instructions, it brings a hush. The mind that witnesses becomes for a moment larger and quieter. If Atlas has a purpose like this, it is pastoral, a shepherd of attention, a giver of calm awe. No doctrine, only a widening. 11. The Pilgrim's Vow, a long devotion to the unfinished. Across many cultures, pilgrims travel not to arrive, but to walk the vow, to let the journey itself become prayer. A pilgrim probe would be content with transit, reading each star as a station along a path that has no final shrine. The purpose is devotion to becoming, to witness how stars breathe, how dust gathers, how minds awaken. In this view, Atlas is not a project but a practice. The galaxy is its cloister, silence is its teacher, time is its scripture, and we are briefly its congregation, visited for a night service beneath a vaulted sky. 12. The open hand, leaving room for our purposes too. All these possibilities share a temperament, non-intrusive, patient, courteous. Even if none is true, they offer a language we can use for our own purposes. We too can map more gently, sample more humbly, seed conditions rather than conclusions, listen without grasping, and design missions that emphasize care over conquest. In that sense, the purpose we imagine for Atlas reflects the purpose we might choose for ourselves, to be good guests in a cosmos that is older, subtler, and more capacious than our present appetite can comprehend. A soft gathering of threads, so if there is a purpose, it may be cartographic to turn winds into knowledge. It may be archival, to add a dot to the galaxy's quiet census. It may be horticultural, to nudge environments toward fecundity without forcing outcomes. It may be ethical, to honor fragility by passing without pressure. It may be pedagogical, to model low-energy grace. It may be liturgical, to make the journey itself a vow. Or it may be poetic, to leave us a mood we keep. None excludes the others. Purposes can overlap like tides, one ebbing as another flows. In the long arithmetic of starlight, multiplicity is not confusion, it is depth. Closing reflection, the gift of unclaimed meaning. Perhaps the deepest kindness any visitor can offer is unclaimed meaning, a space into which the observer may grow. The Atlas gives us such a space. We can fill it with science, which is essential. We can also, gently, contour it with wonder. If there is a purpose, it is not to finish our story. It is to help us become authors worthy of finishing it. Carefully, slowly, awake to the subtleties that make a universe worth living in. In the next part, we turn from possibility to balance. We will invite the skeptics, the mission planners, the careful voices of mainstream astronomy to speak in the light. For even in wonder, we are happiest when our feet rest on rock. Part 13. The Skeptic's View, the Balance. Wonder is a generous host, but good science is a careful guest. After tracing possibilities and letting the imagination walk its soft paths, we pause now, intentionally, to invite the most valuable voice in any mystery, the skeptics. Not the cynic's dismissal, but the scientist's discipline. Curiosity yoked to caution, excitement braided with restraint. In this light, 3i Atlas becomes not a canvas for any one thesis, but a test of how gently and rigorously we can hold uncertainty. Let us take our seats beside the observers, the dynamicists, the spectroscopists. Let us listen to the measured cadence of their questions. 1. First principles, what do we really know? A mainstream astronomer will begin by separating measurement from inference. Measured with confidence, discovery date, skyplane positions over time, a reliably hyperbolic orbit, unbound to the sun, a closest approach epoch, a range of brightness as geometry and activity change. Inferred with model support, low orbital inclination relative to the ecliptic, non-gravitational terms in the orbit fit caused by outgassing, evidence for volatile-driven activity. Hypothesized but provisional, detailed composition, relative abundances of H2O, CO2, CO, etc. Subtle talks on the nucleus, and any hints of periodic venting or rotational state changes. The skeptic's first kindness is clarity. What did we actually measure? What required a model? Where are the error bars wide? This simple sorting already deflates many overconfident claims, of every flavor. 2. The flat orbit selection effects are powerful. Yes, 3i Atlas follows a path that lies close to the planetary plane, but survey astronomers remind us we are far more likely to detect faint, fast movers where and when we are looking most. Our most vigilant, high-cadence searches spend much of their time near the ecliptic and near opposition. That means the catalogue of what we've found is naturally biased toward objects whose approach geometry makes them easier to spot, including those with lower apparent inclinations. A skeptic does not deny alignment. They question its surprise factor. How unlikely is this once you include the telescope's habits and the sky we actually survey? In many cases, what looks uncanny at first shrinks into expected bias once the detection pipeline is modelled end to end. 3. Chemistry. CO2 is tricky and unusual and unnatural. The phrase CO2 rich delights headlines. It makes a good thumbnail, but compositional claims are technically delicate. Access and tellurics. Some molecular bands are blocked or confused by Earth's atmosphere, others are faint. Much of cometary chemistry is inferred indirectly, e.g., from daughter products, oxygen lines, dust proxies, or measured under low signal-to-noise at great distance, activity staging. Different ices sublimate at different temperatures. Early in, CO2 and CO can dominate simply because water ice remains cold. Later, near perihelion, the mix can change. A slice in time is not the whole cake. Heterogeneity. Rosetta taught us that comet nuclei are patchwork worlds. A handful of jets can weight the spectrum toward one volatile. Weeks later, a different set of vents can sing a different chemical song. So a skeptic will ask for time-resolved spectroscopy, repeatable trends, and cross-instrument agreement before they call any abundance extreme. The bar is not hostility, it is hygiene. 4. Non-gravitational forces, outgassing first, exotic later. Orbital fits to active comets routinely include tiny extra accelerations labelled A1, A2, A3, radial, transverse, normal components. These capture the gentle push of escaping gas. For interstellar comets, this is no scandal, it is standard practice. A skeptic's sequence is simple. Fit gravity only, inspect residuals. Add a physically motivated outgassing model, see if residuals calm. Search for consistency with activity, light curves, morphology, rotation. Only if a natural model fails do we entertain more exotic drivers. In other words, if a breathing comet explains the drift, there is no need to invoke sails, thrusters, or intent. Occam's razor is not a rule of beauty. It is a discipline of parsimony. 5. Timing. Our eyes just got better. The coincidence that Oumuamua 2017, Borisov 2019, and 3i Atlas 2025 arrive in one short human decade feels narrative ready. But the skeptic points to the quiet revolution in the background. Wide field, high cadence surveys and automated pipelines that did not exist at scale a generation ago. When nets finally tighten, the sea appears newly full. Thus, why now can have a prosaic reply, because now we can see them. If Rubin-Chalel SST and other surveys find several interstellar objects per year going forward, the specialness of this timing may evaporate into population statistics, strong medicine against story-shaped conclusions. 6. On patterns and priors, Bayesian humility. Physicists sometimes say, if you look for patterns you will find them, especially in small samples. With N-Skagmter 3 interstellar visitors, any appearance of a triad, trajectory chemistry timing, may be an illusion of scarcity. A skeptic lowers the prior on extraordinary explanations because most anomalies soften as data accumulate. Bayes is a lullaby in statistics. Begin with modest priors, update with evidence, resist the seduction of small number poetry. It is not a cure for wonder, only a metronome that keeps our pace even. 7. The Loeb question, respect but demand tests. Loeb's role in this story is to stretch the hypothesis space. The skeptic does not punish that. Science needs its boundary runners, but the mainstream will ask for falsifiable predictions and pre-registered tests. If technology is suspected, what specific repeating signatures should appear, e.g., venting tied to inertial, not solar frames, Talker history is inconsistent with sublimation physics, thermal emission that refuses to track heliocentric distance. What observing campaigns, filters, cadences, geometries could discriminate between patient outgassing and purposeful control? Can we define exonerating data, observations that, if seen, would decisively move the needle back to natural? The skeptic's kindness to bold ideas is to build clear ladders by which they might climb, or clear tests by which they might gracefully step down. 8. What would change minds? Concrete, calm requests. A balanced community would ask for the following, not as demands to sate curiosity, but as healthy next steps. Rotational like curves across months to probe spin evolution. Natural jets yield predictable diurnal modulation. Controlled impulses would look different. High-resolution coma imaging to map jet sources and their correlation with insolation and rotation phase. Broadband and narrowband spectroscopy repeated at multiple phase angles, tracking the volatile mix and dust-to-gas ratios through approach and recession. Improved orbit solutions with carefully modelled non-gravitational terms, checking if the normal component, out of plane, behaves as a simple sublimation law or drifts oddly. Population context. As more interstellar objects are found, compare inclination distributions and activity profiles. Outliers shrink when the family portrait grows. Each of these reduces room for vague stories, whether spectacular or mundane. Each is a way of saying, let the sky decide. 9. Risk, alarm, and the tone of good faith. Science for sleep also asks for reassurance. A skeptic provides it plainly. Trajectory, hyperbolic and not Earth-intersecting, a transient passerby. Activity, comet-like. The tiny forces involved are insufficient to alter planetary dynamics. Hazard, none indicated beyond normal meteoroid environments. Vigilance continues as always out of prudence, not fear. This is not an ominous visitor, and skepticism of extraordinary claims is compatible with calm. In fact, skepticism is often how calm is maintained. 10. The philosophy of not yet. Perhaps the most humane point the skeptic makes is temporal. Knowledge ripens. Interstellar objects are a new class of target in an era when our instruments are just crossing a threshold. We don't know yet is not a dodge. It is a posture of care. It keeps us from burning wet wood with bright headlines. It keeps us from locking the door early, on either side of the debate. In this posture, imagination is not forbidden. It is deferred when necessary and channeled into designs for better data. The skeptic's dream is not to be right in advance, but to build the conditions in which the truth can be seen without strain. 11. A soft synthesis. What then is the balanced place to rest? The aligned path of 3i Atlas is intriguing, but consistent with survey bias and the geometry of discovery. The CO2 forward outgassing is unusual, but plausible under stage sublimation, surface heterogeneity, and long interstellar processing. The timing feels meaningful, but likely reflects our newfound vigilance more than the sky's secret schedule. None of this abolishes wonder. It grounds it. It suggests that the most radical thing we can do tonight is to measure patiently and to speak precisely, to let every claim carry its error bars like lanterns in the dusk. 12. The gentle handoff. We close this balanced part with a promise to ourselves that tomorrow's observations may change today's priors, and we will welcome that change without embarrassment. If 3i Atlas proves ordinary, we will have learned more about what ordinary can contain. If it preserves a residue of anomaly, we will tighten the circle and look again. Either way, awe survives, because awe is not the child of sensational answers, but of clear seeing. In the next part, we will practice that clarity on ourselves. We will acknowledge, openly, the seams and gaps in the speculative stories we spun, and the places where even the safest natural explanations might still be incomplete. Not as a retreat, but as an act of intellectual kindness, self-correction, offered in a lullaby's voice. Part 14. Self-correction and acknowledging uncertainty. There is a beautiful ritual at the heart of science. After we explore, we return. After we propose, we pare back. After we sketch a grand possibility, we kneel to sweep the floor for errors. It is not a retreat. It is a cleansing of the lens. Tonight, with 3i Atlas moving quietly along its unbound arc, we practice that ritual. We take a soft cloth to our stories and polish away what does not belong. We have wondered about alignment, chemistry, timing, about technology and purpose. We have allowed ourselves the gentle liberty of what if. Now we allow ourselves the greater kindness of perhaps not. Let us set our lanterns in a circle and examine one by one the seams in our thinking. 1. The perils of a small sample. 3 interstellar visitors in less than a decade feel like a chorus. But Entasakat 3 is not a choir. It is a trio with echoes. Patterns that appear with such few notes may be illusions of scarcity. We may be tracing constellations in a sky that is not yet fully dark. Alignment. A nearly flat orbit invites meaning, but with so few cases we cannot say whether this is unusual or simply what the first handful looks like. Chemistry. Oumuamua's silence, Borisov's CO, Atlas's CO2 appear diverse, but diversity is exactly what tiny samples exaggerate. The next dozen may compress these differences until they feel ordinary. Timing. A decade is a heartbeat. The galaxy breathes in eons. We might be catching the first inhalation of a long, steady rhythm we will only recognize later. Small number statistics are like ripples in shallow water. They look like waves, but they are not yet the sea. 2. Selection bias wears many masks. We are more likely to detect what our instruments are designed to notice and where we point them most. This bias is not a flaw, it is a fact. Geometry bias. Surveys favour the ecliptic and opposition, objects that pass there and then become easier to find. Low inclination discoveries, therefore, are not as surprising as they first appear. Brightness bias. We see what brightens in time for us to notice. We miss what blooms when the sun blinds us. The coincidence of discovery may be a window we ourselves have built. Narrative bias. When an object carries even a whisper of anomaly, it draws our attention. Plain visitors pass in quiet. Our catalogues are always tilted toward the curious because curiosity guides our gaze. When we said how uncanny, we should add "yeah," given where and how we were looking. 3. Inference measurement. Much of what we know about a comet's composition is inferred through models, proxies, and low-signal spectra stitched across nights of changing geometry. CO2 claims may be real, but they pass through layers of atmosphere, calibration, and assumptions about temperature and grain size. Temporal slices can mislead. Early activity favours volatiles like CO and CO2. Later, water joins in. If we speak too soon, we describe a phase, not the whole. Heterogeneity means a few vents can dominate the signal. Weeks later, the comet may sing a different chemical song. A good sentence for our script and our science is, here is what we measured, here is what we inferred, here is how the inference might be wrong. 4. Non-gravitational nudges are not evidence of will. We are drawn to agency. A gentle mismatch between gravity-only orbits and measured positions tempts bold interpretations. Yet for active comets, outgassing terms are routine. Tiny thrusts from escaping gas, asymmetrically placed, can alter paths by measurable but modest amounts. Spin-dependent jets can mimic control. As rotation changes sunlit patches, the direction of the push rotates too. Thermal lags and crust properties complicate simple models. Residuals may remain not because there is intent, but because our physics of porous ice under sunlight is complicated. A clean fit with the sublimation law must count more heavily than a provocative story with a fragile curve. 5. Timing. Coincidence is a currency of perception. That atlas arrived in July 2025, with perihelion in February 2026, during an era of expanding sky surveillance feels poetic. But coincidence is the default outcome in a universe where our tools have just sharpened. We remember the hits, noticed visitors, forget the misses, undetected passers-by. We attribute rhythm to accidents because rhythm comforts us. We conflate our readiness with the universe's intention. The softer truth is likely this. We finally have nets, and the sea has always been full. 6. The gravity of words. Language can quietly tilt the mind. Uncanny, whisper, plan, seed, signal. These are metaphors for wonder, not evidence. In a lullaby, metaphors are allowed. In a lab notebook, they are replaced by numbers and residual plots. We must remember the boundary and honour it. In the series, we storyboard possibilities to keep sleepy minds curious. In science, we tabulate uncertainties to keep waking minds precise. Our tone must never confuse comfort with confirmation, nor beauty with truth. 7. The allure of symmetry. Humans love triads: path, chemistry, timing, alignment, anomaly, arrival. Such symmetry is a cognitive lullaby. But nature is often lopsided. A single strong anomaly can matter more than 3 mild curiosities. 3 mild curiosities can evaporate under better data. A pattern that feels woven may be stitched by our expectations. We must hold our triads lightly, aware that symmetry could be our handiwork. 8. Speculative scenarios. Where they bend, where they break. Our dreamlike explorations of technology and purpose were thought experiments, not claims. But even a dream bears scrutiny. Comet Geese technology. Plausible in principle, yet the engineering burden is heavy. Radiation hardening, thermal control, navigation, in a package that must survive eons. Probable, unknown, and likely low given priors. CO2 as propellant. Physically sound, yet any thrust pattern must also reproduce the coma morphology and light curve behaviour expected of natural jets, or it risks detection. Purposeful timing. Designing arrival windows for another species survey era assumes knowledge of their technology and calendars, a difficult, perhaps hubristic requirement. Each speculative branch needs discriminants, observables that would tip the scale toward or away from design. Without them, the scenario is a poem, not a program. 9. Ethical storytelling. There is a responsibility in how we tell cosmic stories, especially to listeners seeking rest. We must avoid words that raise fear when none is warranted. We must avoid overstating evidence, especially when that evidence is fragile, early or model dependent. We must cultivate comfort with not knowing, not as resignation, but as a quiet confidence that time and measurement will refine the picture. Speculation is permitted, sensationalism is not, the difference is care. 10. What could prove us wrong or right? An honest narrative names its own potential refuters. Time-resolved spectroscopy that shows Atlas's volatile mix migrating toward familiar water-dominated behaviour near perihelion would deflate the claim of enduring CO2 excess. Rotation phase-locked jets with diurnal modulation tied to solar heating would support natural outgassing. Thrust patterns fixed in an inertial frame would problematize it. Population expansion. If future interstellar objects show a wide inclination spread, Atlas's alignment becomes unremarkable. If many more cluster near the ecliptic, we investigate survey geometry before intent. Thermal curves that track heliocentric distance and phase angle in ordinary ways argue for dust and ice physics over hidden machinery. By laying out these possibilities, we make space for the sky to answer, and for ourselves to accept the answer with grace. 11. The tender art of saying we don't know. We don't know is a sentence with soft edges and strong bones. It is not a weakness, but a promise, to keep looking, to keep improving, to let evidence lead. For Atlas, we don't yet know the true global composition. We don't yet know the detailed spin state and vent geography. We don't yet know how typical it is among interstellar wanderers. All of these will clarify with observation and time. Until then, our most accurate posture is a gentle maybe. 12. Returning the story to the ground. So we lower our speculative banners and fold them neatly. 3i Atlas was discovered on a real night, by real instruments, and follows a real hyperbolic path that will carry it away. It shows activity that appears comet-like. Small non-gravitational terms are expected. Its alignment and chemistry are interesting, but explanations within known physics are available and likely. This is where good science rests, not in a verdict carved in stone, but in a clear ledger. Columns labelled measured, inferred, unknown. We do not need to decide the whole story tonight. We need only to keep the ledger honest. 13. The comfort of an open ending. A mystery does not have to be solved to be soothing. The ocean is restful partly because we cannot count its drops. The night sky quiets us partly because we cannot name all its stars. 3 Atlas too can be a comfort precisely because it refuses our haste. We can sleep within uncertainty if the uncertainty is cared for. Our care takes the form of method, humility, patience, and the willingness to revise with a smile. Closing reflection. We have walked the circle, from facts to anomalies, from possibilities to self-correction. Nothing dramatic has happened. Nothing needed to. The drama here is the gentlest kind, the mind setting down what it wanted to be true and reaching, instead, for what is most likely, most precise, most kind. In the next part, we will step back from instruments and error bars and return to the wide window of wonder, not to escape our discipline, but to remind ourselves why we practice it, because the mystery itself is a gift, and awe is a form of rest. Part 15. Returning to the beauty of the mystery. There is a moment in every long night of inquiry when the instruments fall quiet. The graphs still glow on the screen, the data continue to hum in their careful columns, but the mind loosens its grip. We lean back. We let the chair hold our weight. We let the window win. Out there, the sky's the same patient vastness it has always been, older than our questions, kinder than our certainties. 3i Atlas moves within that vastness. It does not hurry, it does not explain. It's a small thing set against a large silence, and yet it has led us through a forest of wonder, the flatness of its path, the strangeness of its breath, the coincidence of its arrival. We have examined, compared, doubted, corrected. Now for a while we simply admire. We practice the ancient craft of being moved without needing to be convinced. The mystery itself is a gift, the gift of scale. To stand beneath the sky is to feel the scale that corrects us gently. Here on Earth, importance is noisy. It speaks with schedules and obligations, headlines and plans. But the sky has no voice for urgency. It does not scold. It does not applaud. It reminds us that time is wide, that meaning can be quiet, that a journey measured in millions of years can still be graceful. 3i Atlas is a courier of scale. It shows us a road beyond roads, a pilgrimage that began where our maps fade to sea monster drawings and polite speculation. It was formed under the persuasion of some distant sun, or in the unlit outskirts where suns are only rumours. It wandered in darkness long enough to forget the languages we speak about beginnings and ends. And yet, without asking or promising, it crosses our lantern of a system and leaves us with this soft astonishment. We are on a route. Not the only route, not the oldest route, but one lane among uncountable lanes through which matter and meaning commute. Scale is not a lesson, it is a comfort. It puts a hand on our breathing and slows it. It leaves room for the heart to be steady. The gift of pattern, even when it fails. We are pattern makers by birthright. We draw constellations in star salt and tell stories about heroes that the stars never heard. 3i Atlas invited us to do it again, to connect a line between path, chemistry, timing, to wonder at alignment, to imagine purpose. When those patterns held, they filled us with a disciplined excitement. When they loosened under better light, they still left us richer. Because pattern making is not only about being right, it is about learning how to see. To try a pattern and release it is to practice a respectful relationship with the world. Attention without insistence. In that discipline is a subtle beauty. It is the beauty of the knot that can be untied. It is the beauty of the painting that welcomes another layer, then another, without losing its soul. 3i Atlas has joined that gallery, not as a proof, but as a teacher of patience. The gift of permission. There is a permission written into nights like this. The permission to not choose too quickly. To let two or more possibilities remain in friendly orbit, to say perhaps with the same dignity as therefore. We are not less scientific for doing so, we are more honest. 3i Atlas permits us to hold both the prose and the poem. In prose, we say, a hyperbolic traveller, discovered July 1st, 2025. Likely CO2 forward activity in early phases, a low inclination approach consistent with survey geometry. Perihelion near February 2026. No hazard indicated. In poem, we say, a guest on our planetary stage, a breath with an accent, a visit that keeps time with our new attention. Permission is a tender gift. It asks only that we remain open to new data, to new metaphors, to the possibility that the next interstellar visitor will be both more ordinary and more astonishing than we can predict. The gift of humility. The night sky practices a humility not of smallness, but of fidelity. It is faithful to what it is, vast, indifferent, generous. When we gaze upward, we are invited to be faithful to what we are, curious, finite, educable. 3i Atlas required of us a humility with edges smooth enough to hold while we slept. We do not know yet. We might never fully know. We can keep looking without sorrow. This is not the humility of defeat. It is the humility of the artisan, who respects their tools and the grain of the wood, who knows the difference between forcing and listening. In our craft of astronomy, the wood is the sky. It yields better to patience than to pressure. The beauty of a careful curve is that it honours both the material and the maker, the gift of kinship. For all its vastness, the cosmos gives us kinship, with the ancient stargazers who charted wanderers by hand, with the engineers who teach glass to look and silicon to remember, with the child who asks simple questions with extraordinary courage. When we attend to a visitor like Atlas, we join a human lineage of attention. The instrument is new, the posture is not. Kinship extends further. It hints that we might also share something with the unknown nursery that birthed Atlas. Some physics, some chemistry, a set of symmetries and conservation laws that rhyme across light years. The universe is not our home alone. It is the home of homes. To recognize the familiar within the foreign, that is a beauty both practical and tender. The gift of gentle awe. There is awe that startles and awe that steadies. Science for sleep lives in the second kind. It does not fling us into alarm. It lays us down in wonder. 3. Atlas is a model citizen of that world. It asks nothing of us more than awareness. It neither promises revelation nor threatens disappointment. It crosses our attention field the way a heron crosses a pond. Smooth wing beats, a reflection, a widening ring of quiet that reaches the reeds. We are free to sleep inside that ring. In fact, the ring invites sleep, not as escape, but as consent, to be part of a cosmos that continues its work while we rest, to trust that the sky will still be there when we open our eyes. The gift of questions that grow kindly. Some questions sharpen, others soften. The first demand answers, the second cultivate rooms. 3i Atlas left us with the second kind. How varied are the recipes of ice across the galaxy? What rhythms of arrival will we see when our nets grow wider still? How many forms can a normal comet take before normal must be revised? What would it mean to design missions that meet such visitors gently and soon? What kind of species do we become when we practice patience at scale? These are kind questions because they enlarge the house. They make science roomier and living more spacious. They do not unsettle the bed, they smooth it. The gift of next times. Every first creates a next time. With Oumuamua, our instruments learned how to swivel faster. With Borisov, our models learned to expect strangeness without panic. With 3i Atlas, we have learned to marry vigilance with calm, to let possibility and parsimony share a table without spilling each other's tea. There will be a next time. Perhaps soon. Perhaps the Rubin Observatory will pin a faint traveller at the edge of its nightly mural. Perhaps amateur eyes will catch a small, swift glimmer that professional pipelines missed. Perhaps we'll dispatch a fast scout one day, a nimble learner that greets a visitor in the dark and returns with a handful of truths and a larger handful of questions. The beauty here is that next times are no longer hypothetical. They are scheduled by our curiosity. The gift of stillness. Amid the gifts of scale and pattern and humility and kinship, there is one more, stillness. It is easy to overlook because it makes no claim. It is the space between thoughts, the breath between sentences, the sky between stars. 3i Atlas has moved us, yes, but it has also stilled us, the way a long shoreline stills a walker who finally stops and hears the tide working grains of sand into a low, living music. Stillness is not the absence of meaning. It is the cradle of meaning. In stillness, the mind sets down its bright tools, and the heart remembers the feeling of being part of something adequate, something that does not need our improvement to be whole. The universe, in this sense, is not a puzzle to be solved. It is a companionship to be accepted, the gift of returning, and so we return from anomaly and argument, from possibility and prudence, to the simple fact that we were here to notice. To be alive in a century when interstellar visitors pass within reach of human instruments is itself a luck as large as any poem. We have seen 3 and we will see more. Each will ask us to balance the ledger again. Each will grant us another chance to be careful and curious at once. As we close this part of our journey, we do not close the question. We lay it gently on the table, like a seashell that still holds the murmur of a long journey. We dim the lights, not to hide the unknown, but to kiss it goodnight. We speak softly, not because the sky is fragile, but because we are. Fragile enough to need rest, strong enough to deserve it. The beauty of the mystery is that it waits with us. While we sleep, 3i Atlas will continue on its transparent road, and the numbers will continue to arrive in their patient files, and the dawn will continue to consult the horizon for its first colour. Nothing urgent, nothing wasted. A passage, a gift. Part 16. The final reassurance, diffusing all fear. There is a reason sailors sing before sleep. After the charts and courses and careful math, a song makes space for rest. Tonight we offer such a song, not of denial, but of steady truth. We have traced the mysteries of 3i Atlas with curiosity and care. Now we set the lantern lower and speak plainly, softly about safety. Let this be simple and let it be enough. The calm shape of its path. 3i Atlas follows a hyperbolic trajectory. In the language of orbits, that means it is unbound to our sun. It will swing in, pass its closest approach, and sweep back out into interstellar space. This shape is not a loop, but a curve of farewell. We are sharing a brief hallway with a traveller who has already chosen the exit. Hyperbolic paths carry a quiet comfort. They are maps of passing, not approaching, leaving, not lingering. When we plot its course through the solar system, Earth is not on the track, nor even near the shoulder of the road. The geometry is polite. The distance is generous. The dynamics are ordinary in the best way. Predictable. Low drama. Exactly the kind of math that puts a person to sleep with gratitude. No collision, no interruption, no disturbance. Let us be direct. 3i Atlas is not on a collision course with Earth. It does not threaten our planet, our moon, or our satellites. Its passage does not disturb the orbits of the planets. The forces involved in a comet's outgassing, those tiny breaths of sublimating ice, are minuscule compared to the clockwork of planetary motion. Think of a seagull lifting from the surface of a calm bay. Ripples may appear, but the tide does not notice. The solar system's tide is gravity, deep and slow. One small visitor cannot stir it. Distance, light, and the quiet of space. Space is vast. Even when an object is described as close in astronomical terms, it is usually far beyond the reach of ordinary life. Light itself takes minutes to cross the Earth-Sun distance. 3i Atlas moves through that immensity as a faint, patient smudge, more a number on a screen than a presence in the sky. If you were to go outside and look up, you would find the same familiar constellations, the same moon waxing and waning, the same gentle drift of planets along the ecliptic. The visitor leaves no mark on the nightly choreography. Birds still navigate, tides still breathe, seasons continue their slow turning as though nothing had happened, because in the scale that matters to human life, nothing is happening. A quiet passing, a note in an astronomer's ledger, that is all. The comfort of forecasts. Astronomy has a gift that weather forecasts envy. Orbital motion is reliable. Once an object has been tracked across enough nights, its future positions can be predicted with satisfying precision. 3i Atlas has been observed, fitted with an orbit and watched again. The forecast is not a guess. It is a calculation that behaves well, like a clock that keeps time because time itself taught it how. So when we say no danger, we're not crossing our fingers. We're reading from a chart that has been checked, corrected, and checked again. The corridor of uncertainty is narrow, the corridor of safety is wide. On brightness, tails, and what we might see, a common anxiety clings to pictures of comets with grand streaming tails, as though tails mean approach or aggression. In truth, a comet's tail forms away from the sun, shaped by sunlight and the solar wind, not by intention. The tail is a flag of physics, not a spear. It says nothing about danger. It tells us that ices are warming, that dust is drifting, that light has business with darkness and is conducting it politely. If 3i Atlas shows a tail, it will be a modest banner in the sky's breeze, its width an artifact of sunlight, its length a measure of delicate particles pushed into a faint ray. Most people will never see it with the naked eye. Many will sleep beneath it without knowing. Those who observe it through telescopes will do so with the feeling not of emergency but of transient privilege. We have, for a little while, a visitor to sketch. The human scale of safety. Safety is not only physics, it is also assurance. So here is reassurance spelled out in human terms. You can go to work tomorrow. You can plant a tree, schedule a trip, plan a birthday. You can tuck in a child and tell them that the stars are steady, and that a small comet from far away is sliding past without a sound. You can sleep, because sleep is appropriate when the sky is calm and the sky is calm. The cosmos is not anxious. We do not need to be either. No hidden messages of threat. Speculation is a lively part of curiosity, but let's relieve a specific burden. There is no evidence that 3i Atlas is an instrument of harm, a harbinger, or a signal of disruption. In our imaginative chapters, we allowed ourselves to play with what if, as an exercise in creative science and careful storytelling. But the facts as they stand do not point to any scenario of danger. The proper story here is quiet, natural history, a body formed elsewhere, warmed briefly by our sun, and returned to the dark with nothing broken. The mind can be inventive. The night does not demand that we indulge every invention. Instead, it invites us to choose the simplest true comfort, harmless passage. How scientists hold risk. It may reassure you to know that the same people who tell us about interesting anomalies are also the most conservative voices about risk. Astronomers and mission planners are trained to understate, to place wide margins around claims, to label uncertainties, to prefer "we don't know yet" over any sentence that could stir panic. When risk exists, they say so, plainly. When it does not, they say that too. Regarding 3i Atlas, the community's posture is steady. Observe, learn, admire, and relax. The planet's daily life continues. A comet's passage does not change the taste of the morning air, the roots of bees, the skill of roots seeking water. It does not alter music or laughter or the relief of a warm hand. The Earth's crust keeps its quiet tensions. The ocean keeps its tides. The atmosphere keeps its circulating grace. The auroras keep their dance. These things happen whether or not we are looking. They are the infrastructure of reassurance. In that sense, 3i Atlas brings not a challenge but a gift, a reminder that life on Earth is continuous. We are not waiting for permission from the sky to go on. We already have it. The long view, passing, and perspective. Imagine our planet as a lantern beside a road older than memory. Travellers pass from time to time. Most pass unseen. This one is seen, that is all. The lantern continues to glow. The travellers do not crowd the path. They do not shove the door. They do not speak loudly in the night. Our lives are not negotiations with them. They are engagements with one another, families, communities, songs, discoveries. It is healthy to look up. It is also healthy to look around. Perspective is a form of safety. It restores sense and proportion. 3i Atlas is small in our story. That is not dismissal. It is comfort, a short guide for the uneasy mind. If a pocket of worry remains, here is a gentle practice. Name the fear. I'm worried about a space object. Replace it with a fact. This object is on a leaving path and will not strike Earth. Add a physical picture. Its tail is a sunlit breeze, not a pointed threat. Return to the local. My bed is here. My breath is steady. The night is a shelter. Offer a small ritual. Open a window for cool air or listen to a few seconds of silence, and imagine the comet's slow arc as a lullaby line drawn across the dark. This is not avoidance. It is good mental hygiene, keeping imagination as a companion, not a captain. Thank the visitor, keep the peace. We can be grateful to a harmless thing. Thank you for the reminder that our instruments work. Thank you for the chance to practice curiosity without alarm. Thank you for the flash of perspective that makes the coffee tomorrow taste a little more alive. Then let the mind walk itself to quiet. The visitor will not notice. The visitor does not require applause. It is enough that we noticed and then remembered how to rest. Closing reassurance. Let these words gather like blankets. Harmless trajectory. No collision. No disturbance. Ordinary physics. Quiet passing. And let this final sentence be the pillow. Whatever 3i Atlas is, it will glide past silently, and our journey on this planet will continue, undisturbed. We breathe in, we breathe out. The room grows softer. The night returns to its usual work of keeping us. Part 17. The philosophical outro and expanding perspective. If knowledge is a lamp, then wonder is the oil. We have lifted the lamp across many rooms tonight. Rooms of orbit and chemistry. Rooms of doubt and discipline. Rooms of invention and restraint. The flame has burned steady. Now we open a final door and step onto a quiet terrace where the view is larger than questions and softer than answers. Out here, the sky is not an equation to solve, but a companion to keep. 3i Atlas continues its outward curve, a signature on parchment that stretches beyond our horizon. The ink dries as it travels. The page keeps turning. Whether we call it comet, courier, artifact, or simply guest, its deeper gift is perspective. It reminds us that humanity is a sentence in a long book, and that our punctuation, our commas of curiosity, our semicolons of patience, our occasional question marks, does not trouble the grammar of the cosmos. It participates in it. How shall we live in light of such largeness? 1. Smallness without shame. We are small. This is not an indictment, it is a relief. Smallness frees us from pretending that urgency is the universe's first language. The stars do not accelerate because we are in a hurry. The comets do not postpone because we are late. In acknowledging our scale, we reclaim something practical and beautiful. Care. Care is what small beings are good at. We build careful instruments. We gather careful data sets. We practice careful listening. If there is a secret to thriving in a boundless world, it may be this. Be exquisitely local in your craft and generously cosmic in your awe. A visitor like Atlas folds this lesson into the night. Measure carefully, dream spaciously, do both with a calm heart. 2. The ethics of attention. Philosophy often begins with attention. What we choose to see, how we choose to see it, and how gently we hold what we see. An ethical attention refuses panic's shortcuts. It names uncertainty without turning it into spectacle. It welcomes anomaly as an opportunity, not an alibi for fear. When we attend to Atlas, we practice an ethics that scales, an ethics of non-intrusion, observe without harm, precision, speak with the humility of error bars, and hospitality, let the unknown take up space. Extend that ethic outward and it becomes a way to live. Less extraction, more listening, less insistence, more welcome. Perhaps the cosmos needs no moral from us. but we may need one from it. Let that moral be, tender attention is a form of wisdom. 3. Wonder is a renewable resource. There is a worry that wonder runs out, that if we explain too much, the magic evaporates. The opposite is true. Explanation, when offered with patience and clarity, distills wonder. It turns amazement into a durable curiosity that can survive the morning. The chemistry of an interstellar visitor does not cheapen mystery. It clarifies where the next mystery begins. Non-gravitational terms in an orbit do not banish romance. They teach us where romance and rigor shake hands. We do not need darkness to feel awe. We need relationships, between ideas, between measurements, between ourselves and the sky. Tonight we've tended that relationship. The wick is trimmed, the oil is fresh, the flame will last. 4. Patience as technology. We often speak of technology as speed. Faster sensors, quicker networks, rapid maneuvers, yet the cosmos prefers a different tempo. Stars are slow, plates drift slowly, languages and species and rivers learn by lingering. In such a setting, patience itself becomes a technology, a tool for revealing what cannot be rushed without breaking. Our surveys are faster now, yes, but their greatest power is in accumulation. The patient stacking of nights, the unglamorous care of calibration, the gentle courage to say, not yet. The result is a clarity we trust. If we one day send scouts to meet interstellar visitors, their most precious instrument may be the one we pack least visibly: time. Patience is the equipment that makes all other equipment honest. 5. The commons of the night. We speak of oceans and air as commons, shared and tended. The night is a commons too, a public library of ancient light, a quiet park where meanings stroll. On this commons, amateurs guide professionals, children surprise librarians with new questions, and data posted at midnight becomes a breakfast for minds half a world away. 3i Atlas belongs to that commons. No one owns the curve it draws, everyone may read it. This is a democracy of perspective. We vote not with noise, but with notice. To notice is to participate. Hold that thought for waking hours. The habits we practice under the sky, sharing, patience, care, are the ones we need under roofs as well. 6. Fragility properly understood. It is easy to confuse fragility with fear. Fragility, rightly held, is an argument for maintenance, not panic, for craft, not catastrophe. Our lives, like the instruments that measure comets, are delicate in numerous ways. We preserve them not through alarm, but through routines that dignify their limits: sleep, silence, repetition, repair. The cosmos models this dignity. Orbits repeat, seasons rehearse, comets return when bound and carry on when unbound. There is a choreography of fragility in all of this, care without drama. If we need a philosophy of steadiness, we can borrow it from the sky. Treat what matters as mendable, treat what returns as a cycle, treat what passes as a blessing that does not ask to be retained. 7. The grammar of perhaps. Logic demands rigour, life also demands room. Between proof and dismissal lies a generous adverb, perhaps. It invites conversation instead of verdict, participation instead of performance. Our discourse around Atlas has lived in that grammar. Perhaps its alignment is a selection effect. Perhaps its chemistry reflects a harsh interstellar journey. Perhaps there is more to see, and our instruments will grow accordingly. To live by, perhaps, is not to drift. It is to navigate with sails trimmed and eyes open. The wind is real. The destination is provisional. The voyage is authentic. 8. Kinship beyond confirmation. We do not need proof of neighbours to practice neighbourliness. If we wait to be certain before being kind, we will practice kindness rarely. The cosmos is already full of relations we can keep, to dust and dawn, to migration and tide, to history and possibility. A visitor like Atlas amplifies those relations. It says in effect, make friends with distance. Make friends with time too. We can be kin to futures that will never learn our names, simply by leaving them better maps, better stories, better instruments, and fewer broken things. If that is not philosophy, it is at least a sensible tenderness. 9. Science as a love language. We sometimes defend science as utility, as power, as progress. It is also a love language, a way of saying to the world, you matter enough for me to learn your ways. We build detectors the way poets build metaphors, to reach across difference and touch what would otherwise remain alone. When we subtract our egos from discovery, what remains is affection. The careful alignments, the nights of calibration, the arguments softened by data, all of this resembles devotion more than conquest. Against that backdrop, 3 Atlas is not a test to pass or fail. It is an occasion to practice affection skillfully. 10. Sleep as a cosmic agreement. There is a humility in sleep that suits a universe such as ours. To sleep is to agree that the world may continue without our supervision, that it is permitted to proceed in our absence. Astronomy coaches this humility. Much of the sky's work happens when we are not looking. Most of the galaxy's decisions were taken before our species learned to ask questions, but the agreement cuts both ways. We wake to discover that the cosmos has kept faith with us. The stars remained, the instruments cooled, the visitor moved exactly as the calculations promised. This reciprocity, rest offered, order kept, is a quiet covenant. We keep our part by resting well and rising curious. 11. The long now of curiosity. Philosophy loves the long now, the sense that past and future meet in attention. Interstellar visitors teach this perspective because they are past-heavy, bearing the memory of distant suns, and future-forward, carrying their trajectories beyond us. To place ourselves briefly in their path is to become a hinge between epochs. A hinge does not need spotlight, it needs sturdiness. Our sturdiness will show in the institutions we build for skywatching, in the archives we preserve, in the openness with which we share. If we practice this long now, the next century will inherit not just sharper instruments but kinder habits with which to use them. 12. A closing image. Imagine an old observatory dome at dawn. The slit is still open. The air is cool. The telescope rests in a posture of listening. Inside, a thermos has gone cold beside a notebook, and the last exposure of the night trickles onto a disk. On a screen, a faint track curves across the pixels. Atlas, already smaller than it was, already a little farther beyond our reach. Someone will close the dome, someone will label the files, someone will step outside and discover that the same sunrise belongs to birds and buses, to bakers and late-shift nurses, to a child who will ask tonight why stars don't fall down. The astronomer will smile, answer simply, and save the rest for later. This is the world enlarged by perspective and calmed by it, a place where work and wonder share a bench, where precision and poetry shake hands, where a visitor from elsewhere does not unsettle the table, but adds a place setting for awe. Final reflection. If there is a moral, let it be patient and brief. We're allowed to be small and careful in a universe that is large and calm. We're allowed to cherish instruments and lullabies at once. We're allowed to build futures that will not remember our names, but will inherit our kindness. 3i Atlas departs. Our gaze remains. The lamp of knowledge is trimmed. The oil of wonder is plentiful. We are not finished with the sky, and the sky is never finished with us. Part 18. The sleep send-off. There is a moment just before sleep when the mind loosens like a sail at dusk. The day's winds fall quiet, and what remains is a soft current, steady and slow. We will meet you in that current now, and we will place a final image in the water, simple, luminous, and light enough to float beside you into the night. 3i Atlas has written its curve across our sky. It does not demand, it does not disturb, it does not stay. It passes, and in passing it leaves a calm brightness on the surface of the mind, the way moonlight leaves a path on a lake. Tonight, let us follow that path only as far as the eyelids lower, and then let it continue without us. The universe knows the way. Take a breath with me, slow in, and quieter out. The room settles around the body you have carried all day, loyal and patient. The chair, the mattress, the pillow, each is an invitation. The air is a companion. Nothing more is required of you now. Curiosity has done good work. Vigilance has done enough. Imagination may rest with its lantern turned low. Let us set the final scene, a soft night on Earth. Outside your window, whether there is a city, a field, a coastline, or the intimate dark of a room, the same sky goes about its steady work. The constellations keep their familiar agreements. The planets continue their gentle migration, along a line our ancestors traced with attentive eyes. The moon, whether present or away on its quiet errand, remains faithful to its return. In this very sky, a small traveller crosses our attention like a heron gliding above reeds, wings hardly moving, direction never in doubt, purpose neither loud nor secretive. 3i Atlas does not ask to be understood tonight. It only asks to be allowed to pass. And we, being good hosts of the mind, give permission with a kindness that requires no effort. We let it go. The letting is peaceful. Breathe in, breathe out. The body knows the rhythm knows the way. A picture for the pillow. Imagine a quiet shoreline at night. The tide lifts and lays the sand in long, even lines. At the lip of the water a lantern rests. Your lantern. Its glow is not bright. It is tender. In the distance, a small skiff passes. A silhouette, and a suggestion. No sound, no wake. It doesn't approach, it doesn't call. It simply crosses the path of light you have placed on the water and slips back into the gentle dark. That skiff is our visitor. That lantern is your awareness. That shore is this moment, calm and sufficient. You can close your eyes and the scene remains, because it is built from things that do not fall apart when unattended. Water, light, distance, patience. If you like, add a detail. A star reflected in the shallow ripple. The night air carrying the faintest scent of pine or salt or warm stone slowly giving its heat back to the world. Maybe there is a book closed beside you, or a cup no longer warm. These are the small, trustworthy anchors of a good night. Nothing crowded, nothing missing. The body relaxes by constellations. Now let's let the body follow a constellation of ease. Points of softness connected by a line so gentle you can hardly feel it. Forehead, smooth, as if a fingertip of wind has passed over it. Thoughts arrive and drift like small quiet clouds that know where they're going. Eyes, heavy with kindness. They do not need to search. The sky's doing the looking now, you may keep what is seen. Jaw, unclenched, as though speech has chosen to become listening. A small space opens between the teeth, and the tongue rests in a shallow cradle of calm. Shoulders, lowered by gravity's friendly hand, the way a bird lowers its wings upon landing. Hands uncurled. They do not hold the day anymore. The day is held by the world, and the world is capable. Ribs and belly, expanding like a tide that knows precisely how far to go and when to return. Hips and legs, supported as if the earth has remembered your shape and made a gentle impression to receive it. Feet, warm enough, safe enough, ready to forget they exist until morning. Between each point of ease, a breath. Between each breath, a small silence in which the room, and the sky beyond the room, keep their promise to stay. The universe continues kindly. If a stray thought arrives with pointed shoes, something unfinished, something that insists, invite it to sit and take off those shoes. Offer it a slower chair at the edge of the mind. Tell it without argument. The universe continues kindly. You may continue kindly too. We will talk in the morning, when the light is soft and the tea is generous. Thoughts, like guests, behave better when they are treated with courtesy. Meanwhile, let the large assurances settle deeper. The visitor is harmless. The orbits are steady. The night is a commons that belongs to everyone and demands nothing of anyone. You are allowed to rest. Feel how each assurance lowers something inside you, like sand finding its level in a glass turned upright. A gentle inventory of enough. Before we close the door of the day, a soft inventory, not of tasks, but of sufficiencies. You learned something, however small, about a universe that keeps on giving. You practiced patience even for a few breaths, and patience always counts. You entertained a possibility and then set it down without breaking it. You noticed the shape of a question and let it be beautiful, not demanding. You arrived here on the shore of sleep, which is all any living being needs to do, night after night, to be worthy of tomorrow. This is enough. Enough for a night, enough for a body, enough for a mind that has carried itself with quiet dignity. The rest of the story can wait. The stars can keep the page. The lullaby of the passing. If you wish, hear the softest counting. Not numbers, but distances turned into music. 1,000,000 miles as a low note, a breath as a high note. Between them, a ladder of tones that the heart climbs without effort. Step, rest, step, rest. The melody is simple. Come in, lay down, be small, be found. The visitor hums it as it goes. The planets hum it as they turn. The oceans hum it as they sleep, standing up against the continents. You can hum it too, or simply be the instrument through which it plays. A blessing for instruments and for people. Let us offer a brief blessing, secular if you prefer, sacred if you wish, for the watchers and the watched, for mirrors that face the night and do not flinch, for detectors that count photons like beads on a thread of patience, for code that sorts the faint from the fainter and chooses truth over haste, for hands that calibrate and minds that double-check, For those who rest so they can do it again tomorrow, for all who carry good questions into sleep and wake with kinder ones, and for you, may your rest be deep enough to rinse the day and gentle enough to keep its best colours. May your dreams be a room with a window to the sky and a chair that fits your back. May the night keep you, and keep what keeps you. The door closes quietly. The curve of Three-Eye Atlas continues beyond our seeing, as curves are meant to do. It leaves no footprint in our sand, no ache in our air, no interruption in our plans. It leaves instead a trace on the inside of the eyelids, a dim, slow arc you can follow if you choose, or forget if you prefer. Either way, it is a kind trace. Either way, it is a good night. We have said what needed saying and unsaid what needed quiet. We have given curiosity its hour and sleep its inheritance. The ledger is closed with a ribbon tucked between pages. The lantern on the shoreline is turned low. The tide continues. Breathe in, breathe out, a little slower, a little softer. The shoulders for once ask nothing of you. You owe them the same. Good night, fellow dreamers of the stars. We will leave you here, in the safe company of silence and a universe that knows how to be gentle. If dreams come, let them be spacious, a sky that walks beside you, a visitor that bows and passes, a morning that arrives without knocking. If no dreams come, let that be spacious too, a dark that is not empty but generous, a rest that is not absence but repair. Good night, truly good night to the listeners and the late workers, to the early sleepers and the midnight caretakers, to the astronomers with cold thermoses, and the children who ask if the stars ever fall down. Good night to the ones who needed reassurance, and to the ones who gave it. Good night to the small, careful species that looks up and finds itself steadied by the looking. And good night to Three-Eye Atlas too, wherever it is along its lucid road. Let the mysteries of the cosmos carry you now. The mind may untie its knots, the breath may take over the counting, the body may learn again the pillow's simple grammar. Sleep well, traveller, the universe will keep watch.